You can read it. Okay. Okay, so welcome once again. I'm looking forward to sharing with you. As you can see, we have diverse backgrounds, as always. It's not always easy to get a group where people are from the same background. So someone mentioned that maybe Eprn focuses more on economic research. Well, partly yes and partly no. Yes, because it's Economic Policy Research Network. Maybe that's one of the main reasons. But at the same time, the trainings, so the trainings are not only focusing on economics, because they're just giving you the skills which you can apply to any field. So sometimes I teach people from public health. We have someone from medicine. So how do you handle data? Let's say, how do you handle, let's say, epidemiological data? How do you manage and analyze epidemiological data to determine, for example, the incidence of diseases? You can still use the same Spss, the same Stata, the same eViews to model whatever you want to model. Data is just, so the skills I give you are supposed to equip you with the ability to apply what you want to do in your own fields. So I might use examples from economics, but as whatever we do, I try to show you how you'll be able to manipulate whatever data set you have, whether it is, whether you want to determine the factors which affect the incidence of diseases, whether you want to determine the probability of winning an election, whether you want, that's political science, whether you want to determine the probability that, let's say, farms will recover from COVID, that's from economics, whether you want to know the factors that determine domestic violence, that is social science. So there are many things that you can do. The skills I give you are basically to enable you to manipulate whatever data sets you have in order to produce what you want to produce and answer the research questions that you are working on. So then some rules of the house. One, if you are more advanced than others, you have to be a little bit patient. I'm going to try to bring the beginners on board. So I request that you be patient up to the level where you feel more comfortable. And along the way, you can keep playing with the data sets. As I try to bring others on board, play with the data sets, and if you have something, you can call me to your computer to show me something you have worked on, and maybe ask a question, and I try to help you move forward a little bit faster than others. And then for those who are beginning, after I bring you on board, I'll try to rush a little bit so that I catch those who are more advanced. So let's just try to find a midpoint. So normally what we do is we have introductory trainings, then we have intermediate trainings, and then we have advanced trainings. So with such courses, that's the easiest way, the easiest structure, that if it was possible to have the same group, assuming we started with this group from the beginner level, then I advance you to the intermediate level, and then I take you to the advanced level, then that is the best way, because you are all at the same level. But it's not always the case, it's not always possible. So we are just going to try to manage the situation. Everyone will have to be patient at some point, especially those who are at a higher level than others. That's number one. Then the second consideration is that realizing that someone is at a higher level than you, don't feel shy to ask. So sometimes people let others who are higher than them drive the class. So don't let others who are higher than you drive the class. Ask individually even if it means, so if you have a question, call me to your computer and I show you something. If you are stuck with something, I'll come and show it to you individually. So it's a group training, but it all comes back to individual learning. So don't say because Christine has seen it, I think I'll feel shy, I feel like I'm the one behind. Please, don't feel shy. It's not a crime to ask, but it's a crime not to ask when you haven't understood. It's a crime against yourself. So please ask. If no one stops me, I'll just continue. If you have a question, stop me to, if you have a general question which you think everyone can benefit from, ask generally. If you have a personal question, call me to your computer. I don't have a research assistant, so I don't have a teaching assistant. I'll be my own teaching assistant. Call me to your computer, I'll come to you. It doesn't matter how many times you call me, you don't have to worry. We are all here to learn. So with that, I think we can get started. So as I already said, I'm Kasim. I'm a development economist, and I'm a senior member of Eprn. I'm a trainer, and I also have a consultancy firm called Mazima Research Consultants. So that's the, if you want to reach out to Eprn, already you know the email, and if you want to reach out to Mazima, still the email is there. Okay, this is just a snapshot of some of the clients I've served. And then the content. So let's look through the content. So along the way you can tell me to go faster, to go slower, depending on how you think. Yes, please.
Sorry, one question. The training is 3 or 4 days?
Sorry?
The training is 3 days or 4 days?
Okay, so the training is supposed to be for 4 days, but I'm going to be with you for 3 days, and then the 4th day I'm going to give you a lot of work to practice. Yes, so because I realize that sometimes I train, and then people go out of this classroom with a lot of knowledge, but then I meet them after some time, they have forgotten. So how do we make sure that the skills you learn, you can apply? So the final day, I want to use it for that. You do a lot of practical exercises, and then along the way, if you have any question, you can even call me. I have no problem with that. So the 4th day is going to be basically for your practice, but it's going to be guided by myself, maybe remotely. Yeah. Okay, so how do we get started? For those who don't have any background, we are going to see the starter environment. I mean the SPSS environment. And so we are going to see the 2 main views, the data view, the variable view. Those who have no idea, I'm going to define for you those ones and how exactly they are supposed to be used. And then I'm going to show you the types of data storage, because when you are working, you need to know which variable am I working with and how do I manipulate it to get what I want, depending on how it is stored. Then I'll teach you how to open data in SPSS format and how to import data from Excel. So maybe these ones, for those who have used SPSS before, you know them, but still I have to bring some others on board. And then I'll teach you descriptive analysis. So I'll teach you univariate, multivariate, and bivariate. And then I'll teach you how to visualize data. Mainly we call it graphic analysis of data, or graphical representation of data. So it's very powerful, especially when it comes to policymakers and other non-technical audiences. So mainly in policy research, it's very important to graphically represent your data. Sometimes people are not interested in your econometric models, which we like in academics. So for them, they are not so much interested. So how do you present your results graphically? And then we shall look at data manipulation. How do we create and modify variables? Then we shall look at some correlation analysis. How do you know the relationship between variables? How do you estimate correlations, and how do you interpret them? And of course, how do you make, let's say, economic sense? When I say economic sense, I don't mean that we are going to, like always, you'll be working on economic variables, but if you're working on public health, how do you make, let's say, health sense, if I may? And then we shall progress into inferential statistics. And here I'll give you some background and then some practical applications of some different tests. And then I'll teach you how to code and analyze qualitative data using Spss. She's happy with that. And then I'll take you to time series and regression analysis. And then from there, I'll take you to panel data analysis. Then another consideration. So as you can see, you may wonder, okay, you're going to teach me how to do inferential statistics, but do I really know inferential statistics? Do I have theoretical background in inferential statistics? And that's also another question. Apart from people being at different levels, also having like, some people may lack the theoretical background. So it's very common to find some people lack theoretical background in some of these things, and so you can't apply practically what you don't know theoretically. That's also the challenge with practical trainings. But normally what I do, although it is practical, I try to make sure that I bring in some little bit of theory to back up what we are supposed to apply practically. So by the time we apply something practically, at least I know that everyone has an idea about the theoretical foundation of what we are doing. Okay, so basically that's it, especially when it comes to topics like time series and panel data. Those of you who have not done econometrics or statistics, you don't have to worry about time series and panel data. So by the time we reach there, so we are going to progress step by step. By the time we reach those last topics, I'm sure everyone will be on board, hopefully. And if you feel you're not on board, please, it's your responsibility to stop me and make me repeat explanations as much as possible until you understand. Okay, so for those who have used SPSS before, you may know all this simple background. Yes, please. Yeah, I think it is important. Yeah. Okay.
I request the lecturer just 2 minutes. I think we can go into details, some of the details regarding logistics in the region. We have 2 days. Starting we have 1 day, but usually at 10, at 30. I don't know if we have set up at 11. It's not far. Let's say it's then at 1, we break for lunch. We need to prepare lunch for the participants. So we have 2 breaks just for you to know. And then we resume around. We can use time rationally because of the rain. Then we can use time effectively. If it is for coffee, do we need to go there for 20 minutes? Maybe 5 minutes we can have a cup of coffee and come here. Maybe the snacks are not good in the classroom because of their smell. You can take snacks there, then you come with a cup of coffee. Then for lunch, I don't need, because you have a small group, we don't need maybe 1 hour. Maybe 30 minutes, maximum 40, then we come. Because we are supposed to close at 5. I don't know if we can go beyond 5 p.m. But let's just have in mind 2 breaks, 1 for coffee, around 10:30 or 11, and then for lunch at 1 p.m. Just clarification.
Okay, thank you, Seth. And I also add to that, I add something about the rules of the game, that as I teach, this is a practical course. You have the data sets. I'm assuming that you save them on your computer. I just tell you which data set to use. You open it. As I show you from here, because I can't show everything one by one, as I show you how to do it, I'm assuming that you are doing it alongside with me. And then if you have a question, that's when you stop me. But don't just wait. So when I'm teaching, I'm assuming you are actually working. So we are learning together, not waiting for something to be done and then you do it later. So then I also, maybe when I'm giving some kind of background information, then you can be following. And then when I say we are now applying, this is how we do this, then I'm assuming that you are actually following. Okay. So for those of you who don't know, SPSS is the statistical package for social sciences, or special package for social sciences, and it's mainly used for both quantitative and qualitative. That's why I want to give, towards the end of the training, I want to give you some little bit of qualitative analysis, and I'll send you some material for that. And then so it used to be mainly for social sciences, but it's not, as I said, it's not restricted to social sciences only. And so some of the advantages of using SPSS is it's very easy to organize data. So everything is very simple. So you have like when you open the SPSS environment, you see a very detailed menu. Almost everything is embedded within the menu. So it's very easy to work with, and it's comprehensive. It has a lot of built-in features, and then also displaying data, especially for graphical representation, is also very easy and very quick. And some people say the interpretation of results is easy and quick, but that depends. Somehow it depends. For like I, for one, who is more interested in SPSS, I mean Stata, I find the results of Stata somehow more appealing, but some people feel like it's easy and convenient anyway. So, but then the disadvantage is that sometimes it is too simplistic. Like you find that sometimes with the built-in menu, you can't do so much of the programming to have some complicated or complex manipulations. Sometimes it's not as detailed as it is for with some of the program-based softwares like Stata. So, but still, we try to maximize, and if I'm assuming that everyone has SPSS on their computers, so we have, when you open SPSS, you have two windows. You have the variable view, and then you have the data view. So those of you who know, already you know, you have worked with them, but those of you who don't know, I just give you some little bit of background. I'm assuming actually that those windows are open. So the variable view, so it's not like Stata or SPS, or Excel, where the data, the variables and the actual content of the data are within the same frame. So with SPSS, we have two frames or two windows. We have the window where the variables are defined, which is called the variable view, and then we have the window where the data can actually be seen, or it's actually contained, and that is the data view. So what you need to know, what do we do with with each of those two views? So with the variable view, of course, as you can expect, is where we define the variables. We define their names, we define their properties. I'm going to show you some of those properties so that when we start working on the actual data, then we will be knowing why are we doing this and how, why don't we do the other way around. So when you know what exactly we are supposed to be doing in the variable view. So the variable view gives you a chance to define how you want your data to be stored, how you want the variables to be measured, indicating which variables are categorical, which ones are continuous. So all those you have to determine yourself as a researcher. So if you are opening data, let's say if you are importing from Excel into SPSS, automatically SPSS will detect the nature and the type of variables, and then it will store it appropriately. But consider a situation where you're entering the data yourself. Maybe you got data from the field and you're going to enter it, so you have to define the variables yourselves and also their properties. So therefore we have to define the elements of the variable view window. I'm going to show it from Excel. So we are going to play with those after seeing the contents of the variable view and also the data view. And then when it comes to the data view, basically you can't change the names of variables in the data view. You can't change the properties. You can only change the data. So which means when you define your variables and their properties in the variable view window, then you switch to the data view in order to make some changes to your data or to initiate the data entry if you are working with a fresh data set. So basically, those are the two windows. I think now we can open them and let me first give you some. So yes, please. Okay, so a little bit on data view. So data view, okay, the most critical one is variable view. Why? Because you may have your data, but then inappropriately define how it's supposed to be stored. I think that's the problem, and you define that in the variable view window. So for the data view, just have the actual data, whether numbers or whether words. You just have the actual data set. That's where the data is stored. The values are stored in the data view. And then the names of variables and the properties of the variables are defined in the variable view window. So in other words, you start by defining those variables, the names and their properties in the variable view window, and then you go to the data view only to have the actual data. For example, if you have a variable like age, you have to write that variable name age under the variable view window, and then you can't enter one's age, let's say 25, in the variable view window. You have to go to the data view window. So the data view is the one that gives you the actual content of the variables. So basically that's, and I'm going to show you how we can enter data, then you'll be seeing the difference between the variable view and then the data view windows. Okay, so this is how it looks like, but we are going to see more when we do some practice. But before that, let me first show you the elements of the variable view window. I try to define each element, and then we start working on the elements after knowing what they are and how to work with them. So when you go to the variable view window, you have these elements as tabs. You have name, you have type, width, decimals, label, values. Then you have missing, you have columns, align, and then measure. There's also another element which is not so much important, and I left it out. But let's look at what they indicate, and then we try to play with some data sets. So the name specifies the name of the variable. Maybe you need to know some of the rules, because we are going to have some variables. So one rule is that when you are specifying the names of variables, you shouldn't have spaces. You may have, for example, marital status. Those are two words. So you cannot have a variable called marital space status. So that's a rule you need to know when you are going to start defining your variables in the variable view window. So if you have a variable like marital status, of course it has two words and you want both of them to be there. So how do you go, I don't know whether we have some markers. Yes, please. So if you have variables like marital status, those are two words. You don't want to use marital, you don't want to use the status only. So how do you make sure that you use marital status? You can use an underscore. So marital underscore status. Or you can just say marital status as one word, depending on which is more important. So that's one of the rules. You don't have to leave spaces between words that make up the variable names. So apart from that, I think it's just the usual way of just think of any variable name. It shouldn't be too long, but it should be easy for you to remember what you were trying to mean. So because you're going to have, let's say, so many variables, sometimes you work with data sets with a lot of variables, so you need to know how you define each variable so that you remember what it is. Okay, so then we go to the type. So what is the type? So the type specifies the storage capacity, it specifies the storage type in terms of how the information is kept. So we have two main types of storage. We have numeric and then string. So string stores what we call alphanumeric characters, let's say alphabetical letters, and then some special characters. So if I have a variable like name, let's say student name, then I have to know that I'm not storing numbers, so I'm storing letters. So I have to write it as, I have to store that variable as string. So string, S-T-R-I-N-G, as I wait for the marker. So then we have another type called numeric. So numeric is the type which stores what we call Arabic numerals, or the numbers 1, 2, 3, like that, even including decimals. So all those are numbers. And but of course there are also different types of numerical variables or numerical values, as I'm going to be showing you when it comes to the data view. Then we have what we call width. So width, so sometimes you find that you enter something, you enter information, and then it is not fitting. Let's say you have names. So, and then you have, let's say, a name like Twizeyman. So you find that that's a long name, and sometimes it may not fit into the column, because the column has a standard size of 8. Of course, you can modify it, but the standard is 8 characters. So you can set the width by increasing it to fit into those, to accommodate those long names and other long information. The same applies to numerical variables. You may have, let's say, national ID numbers, which are 16 digits. So how do you make sure that they are stored? So you can still set the width to 16 so that the national ID can be stored. So that's under width. And then we have decimals. So decimals specify how many decimal places your variables will have. Of course, if it is a string variable, there will be no decimals. But for other variables, it depends on the nature of the variable. If you have, for example, age, you don't need decimals, but some variables may actually need decimals. So you specify, and automatically, depending on which variable you create. For example, if you create a dummy variable, automatically you'll have 2 decimal points. So let's say 1.00 and then 0.00. So then you can specify the decimals to be 0 if they are not needed, or even you can increase them if you need more than 2. So the default is 2 decimals. And then the labels. So the labels, and we're going to play with these ones as well. So the labels specify, they're like descriptions of variables. So if I put like a variable like schooling, let's say I have a variable called schooling, then what does schooling mean? Because I need to have a short name for my variables, then I choose a variable called schooling. But then what does schooling mean? Does it mean number of years of schooling? Does it mean categories like, let's say, primary, secondary, university? So what exactly does schooling mean? So then I can add a label to describe that schooling is going to mean number of years of schooling. So that's that under labels. So you can define, and it helps you because sometimes you create variables and you don't even remember. Or sometimes you can get a data set, let's say a secondary data set. For example, you get Rwanda establishment census from NISR, and then they have a label which you will not remember. Of course, for them, they put the one that they wanted. But then for you to remember what the variable represents, because in the end, it's going to be you to you. So the values, you can specify also the labels for the values. If you have, for example, I'll use an example of gender. I'm entering my data, so if someone is female, I put 0. If someone is male, I put 1. So, but then, when I'm working, I may not always remember. And also, if I'm sharing this information, this data with another person, they will not remember, they will not know whether 0 was meaning female. Because at the time you're doing this, for you remember, you know. But even you yourself, later you might actually forget. If you're working on, let's say, a PhD dissertation and you did this sometime back, almost 3 years ago, and then towards the completion, something you did like more than 2 years ago, you may not actually remember, yet it's you who did it. So how do you tag these values so that you can show, instead of 0, you can see female, instead of 1, you can see male. So there are 2 ways. Of course, I will show you, but there are 2 ways. You can enter these as string variables, string values, female and then male. But then there are some things you cannot do with the strings. That's the problem. So then the better way is that you can define them as numeric values and then add what we call value labels, so that if you want to see what they represent, you can always switch the display between 0 and female. If you want to see female, you can set to see female. If you want to see 0, you can change to see 0. And then it helps you in some of the analysis which cannot be done with the string values. So these are called value labels, and we're going to see how to do them. And then missing. So missing, there's nothing much you can do about missing. It just shows you missing values in that particular variable. And then the columns. So column is almost the same as width, because it still shows you the column width. And of course, the column width shows the spacing, or the capacity in terms of the size or number of characters which can be stored. And then align is just the same alignment, whether left, right, or center, so that's easy. And then the measure. So the measure, here I'm going to show you more about the measure when it comes to the data view. So you can measure, we have mainly 3 main measures. So we have, under measure. And still you are the one to specify to SPSS how you want the variable to be measured. So we have what we call scale. And this is mainly for continuous variables. By the way, if I mention something like continuous variables and you don't know what it means, still you can stop me to explain. If no one stops me, I'm assuming it's fine. So scale is mainly for continuous variables. And then we have nominal. So nominal is normally for categorical. So nominal is normally for categorical variables. For example, you may have dummy variables, 1 and 2, like this. In this case, gender, 0 and 1. Then you can even have more than 2 categories. So all those are categorical variables. Okay, yes, please. The difference between nominal and categorical. Sorry, continuous and? You said continuous and? Categorical. Continuous and categorical. Okay, so for continuous variables, you have no break in between values. You have a continuous range of values, and I can use a function here. So if you have a variable like y, which depends on x, so at any given range of at any given value of x, there must be a corresponding value of y. So there is no break in the function. So there is a continuous range of values. Y can take on any range of values. For example, if you have like let's say interest rate, it can be 10.0, it can be 10.1, it can even be 15.5. So it can take on any range. It's not restricted. So that's continuous. So but also depending on the variable. So if you say age, sometimes like between age 10 and age 11 there could be a break, like 15 point something. But generally speaking, a continuous range of values without a break, that's a continuous variable. And then we have the categorical one. So the categorical one, we have categories. So let's say, so we have, let's say these are categories. So category 1, so in between there is nothing, let's say there's a break, then there's category 2, category 3, category 4. For example, I can use an example of which I already used, the one for schooling. So you can have schooling, years of schooling can be continuous, because someone can have 0, 1, 2, 3, 4, so there's a continuous range. Of course there is a limit, but still in between the 0 and that limit, let's say 0 for someone who had no formal education to something like maybe 20, 23, 22, depending on the system, for someone who has a PhD. So still in between there is a continuous range of values. Someone can have 10, another one can have 11, 17, like that. But then for categorical, then you are restricting. You have, for example, 1 for primary, and then 2, let's say secondary, like that. So that this one is categorical. It is arranged in categories. It doesn't have a continuous flow of values. So that's the difference mainly. Okay, so, but we are going to be seeing some of those and also how to create them. So this is how the data view looks like, and we are going to see how to do it. So far, that's how we are. That's how far we have gone, and now let's switch to SPSS. So if everyone has opened, now let's see how we make use of how we define variables in the variable view. So you can open SPSS, and then we try to come up with an imaginary data set. We create it, and then see how we can play around with those variables in mind. So we are going to assume that we are having some kind of small-scale social survey. We have gone to the field already. We have brought the data. Now we are going to enter. So some of the variables that you can think of in a social survey, we are going to play with them. We could have like the person ID. That's just for numbering purposes. And then we could have the let's say the name. Then we could have, let's say, the age, the gender, marital status, and then we see how to feed in that information in the variable view, and then we can try to feed in the same information in the data view and see how we can manipulate the way the data is supposed to be represented. Okay, so yes, please.
Actually, I guess always before one have information to run into the spaces, there should be a source of that information.
A source of?
A source of that information that you just put into the computer language. So it's like what I'm trying to say. I would try, for example, to data capture sheet or anything that has information that will take your computer and start talking of those other things. So I didn't.
Sorry, can you?
I have not heard you talking something like where the information has come from. For example, I'm trying to take a data capture sheet or information sheet. Does it have relevance in what we have?
For example, like questionnaire?
Yes.
Okay, so someone is asking a question, and let me answer generally because it may apply to everyone. So someone is wondering then what. So we are trying to think of how to enter data, but then don't we have some kind of source for that information? So of course, when you're entering data, you have a source, definitely. Only that in this class, we don't have a source, right? We have to think of an imaginary source. But if you are a researcher and you went to the field, then you have some, let's say, some questionnaires you have filled. That will be the source of information. So here we are going to assume that that source is there. We are going to feed in imaginary information. But of course, when you are doing the actual project, you have your questionnaires, and exactly what we are going to do is what you will do when you have the source information, which is not just imaginary. Yeah. Okay, so let's do this together. We can start with variables, for example, person ID. So, okay, sorry, in the variable view. Okay, so we can start by feeding in variables like person ID. So person ID is going to be the number the person is assigned when you're doing the survey. So person ID, then we can specify the data type. I'm going to show you in details what these data types represent. Yes, please. Yes, we are defining variables in the variable view. So the data view is only for entering and modifying the data itself. But the variables and their properties are defined under variable view. So we are working with the variable view for now to first create some kind of, it's like a template where you're going to put the data, and that template is in terms of the names and the properties of the variables that we want. Okay, so when you see this, you might wonder, so how do we know what type of variables? So we have, let me just tell you briefly. I don't know whether you can see, or let me just put okay, so under type, this is what we have. So you find that you have numeric, as I already explained, is Arabic numerals or numbers, and then you have a string for characters, and then you have comma. Maybe this is where you need to know. So comma represents the way of separating values. Like, for example, as you normally write with money, you have after 3 decimal places from the back, you have commas. So, for example, 1 million. So this, in that case, that is, so it's a numeric value, but it's in comma format, because you need to separate some 3 digits, especially when you're working with money. And then when it comes to decimals, if the variable is stored in comma format, then the decimals will be stored with a dot. So 1 million, 1, comma, 000, comma, 000 point something. So that is comma. And then we have the dot. So the dot, in the dot, it will be the opposite. So you have 1 dot 000 dot 000, let's say, comma 5. So this is dot. And so the dot uses the dot as a delimiter, and then it uses the comma as a decimal indicator. And this is very common, especially in the European system. Like if you, I think even some of the computers with like European system normally have this kind of measure. So that's a dot measure. And then we have the scientific notation. So the scientific one is normally applied when you have numbers which are either very small or very big. So if you have, for example, 0.00000015, or if you have, let's say, 150 million. So those are big numbers. I mean, we have a very small number, and then we have a very big number. So normally such numbers are stored in scientific notation. They are changed into power 10. So then you have something like, you've seen something like let's say -10, or E10, something like that. So that shows that the number has been converted to to scientific notation. It's not the way it appears. So if I have, for example, like 669, let's say let's say 07. This is in scientific notation, and I'm going to ask a volunteer to change it for me into the usual notation. And then I may have 34E, let's say 04. So who can change for me these numbers? You realize the negative and the positive. So these are scientific notations. But then to know what they actually represent, how can we change them into the usual notation we understand? Anyone has an idea? Yes, please. Yeah. Yes. 3, 4, and 340,000? Is it? Okay, let me make it easier. What if it's like that? This will become 340,000? Okay, this is how we do it. 3 times 4? the power of 4, which gives us 340,000. Is it? Does everyone agree? Okay, let me show you how to do it, because when I say to power, then you may not understand how to get something to power. So when it's E, so the E is supposed to show you that this is something to power 10. So E04 it means that you're supposed to have 4 zeros, but then if you have a decimal, then you have to move, so you have to move some decimal places ahead. So you have to move from this decimal ahead to remove this decimal. For example, for this 3.4 to become 34, it means one of the zeros here will go, and then you remain with 3 zeros, right? So it means you'll have 3, 4, and then 3 zeros. 34,000, right? Sorry? Yeah, so yeah, I added this decimal. I added this decimal so that you can see that from the decimal, because these zeros are supposed to be applied after the decimal, and then going forward if it's positive, and then going backwards if it's negative. So if it's okay, in this case I think someone can get an answer, right? 0.6 zeros. Exactly. So instead of writing 0.0000069, then SPSS will write 6.9E negative 07. So this is scientific notation. Sometimes you'll find this in your data set with such very small and very big numbers. In this case, this is not very big. So sometimes it happens with more than like 0.07 and above. That's where you have the number, because this one can be written without conversion, but normally big numbers which are big and mainly more than millions, that's when you have this number converted into scientific notation. Yeah. Sorry? Yes, please. Sorry? Yes, please. Oh, you're wondering about this one, right? This one.
Yes, please. Almost having it written like this.
Can you make it bigger? I'll come to your question, right? Yes. Yeah. Then it becomes, yeah, exactly. Yeah, exactly. So, exactly, this is still the same. It's just a matter of how exactly it's presented, but still, if you still you see that exactly this is the same. If it's like times 10, then to power 3, still you can be able to figure out the corresponding value. Then someone has a question: what does this 04 represent? So this 04 represents the.
I think for that one, it will be 34 power 10 times 3, or you remove dot and then 3. Yes.
Yeah. So I see that. So okay, if you was.
If you use the comma, then the power will remain 4. If you don't use comma, there will be 3. That one. Is it 4?
Like that. You see that? Yeah. So this will be the same. So okay. So someone still wondering what is this 04 doing here? So this 04 is supposed to tell us the number of zeros we have either before or after the decimal point. If it's positive, it's supposed to show us dollar sign or the dollar format is supposed to show that this is information stored in dollars. So specifically dollars, not just any other currency, specifically in dollars. But then under dollars still you can have a custom currency. Then you can specify, for example, Rwandan francs, Uganda shillings, and then you have your information stored as that particular currency. And then you have restricted numbers. These are not very common. Restricted numbers are numbers which are restricted or normalized to be some particular numbers depending on what information you are storing. For example, sometimes you have negative numbers, and then those negative numbers are converted into non-negative numbers. So when you look at them, you may not exactly know what they are, but SPSS understands that this number was negative, let's say negative 10, and then it is now appearing as, let's say, 3 or something else. And then SPSS knows that there is a negative behind those numbers, but they are only restricted to be non-negative in presentation. They're not so common, and when it happens, then SPSS will be able to automatically do the coding for you. Okay, so now, yes, please.
Here, on what we were discussing, for example, on dollar.
Yes, please.
Here on witness, we have around 8.
Okay.
It is 1 year you said you can change it to have one.
Yeah.
You can have more than 8.
Exactly.
How the range of
How do we change it? Yeah, so that's what we are going to. So let's go back to our example. We had started a data set and we had reached the level of putting the type. So this is where we stopped. So we started with person ID. So person ID is going to be a number. Let's say 1, 2, 3, 4. So it's going to be a number. So we make it numeric. So we make it numeric. Okay, and then we click OK. Sorry? You didn't change on width? Yes. We haven't, I think we haven't reached there. So then width, okay, width you can change there if you, so it depending on how you're going to assign numbers. If you're going to have, for example, let's say 1,000 individuals, then you can change the width to 4. So 999, then up to 1,000, those are 4 digits. Yes, please.
Type.
Yes, please.
On that side of the screen and decimal places. Do you use this numbers?
Sorry, do you? Can I, okay, let me come there. Okay, so yeah, just for now, just put in numeric. Width, still you have a chance to change it here if you want. Yeah. So automatically the width is 8. In my case, I had typed in something string. That's why the width was automatically set to 1. But for you, your width is automatically set to 8. Okay, so for me, I'll also change mine to 8 so that we have the same. And then decimals. Do we need decimals? We don't. So if we needed, we would increase just like this. We would increase, but in this case we don't need it. So we need only 0 decimals. And then label. Who remembers what the label is supposed to show us so that we can maybe try to have a label here? Label. Remember the label can have spaces. So when you're defining variables, yes, define without spaces, but then come back to if you want something to look good. Sometimes this label is also going to be used in the representation of regressions and graphs. So, sorry? You have a question? We can leave the label.
Like serial number?
Yeah, like we can, for example, okay, I'll show you mine. I'll say person ID. It's like the same, only that now it appears the way it's supposed to appear, not just person ID one word. So person ID, or I can even change it into, just a moment, into, let's say, serial number or person survey number, because I'll come to you, sorry. So like one time, I'll give an example. I think sometimes things can become confusing. So one time I had a questionnaire and I gave it to enumerators, and then I had person ID, and then someone went to the field, and person ID, they started asking for ID numbers, national ID numbers. So then, in that case, you have to specify when it is person ID to avoid confusion. Then you can say, let's say serial number, or count just number, like individual numbering in the survey, so that it doesn't confuse you you don't confuse it with someone's national ID number. Yes, please. No. It's totally different. We have, I'm going to come to that one. We have what we call variable label, and then we have what we call value label. So in starter, these are variable label and then value label. But in SPSS, this is label and this is value. So what does it mean? You mentioned female and male. To represent 0 as female and 1 as male, that's a value label, and we define that under values, not under label. So the label we are talking about is the description of the variable itself, not the values it has. So putting a tag, describing the variable is a variable label, which you do under label. Then putting a tag on the values of that variable, 0 male, 1 female, that one is a value label. You are tagging the values, putting a description on the values, not the variable. So the variable is like a container, the values are the actual content. So putting tags on the content is a value label, and that one is done under values, and then the variable label is put under label. So in this case, person ID, adding a description, what does person ID represent? Then if it's gender, what does gender represent? Gender of the person, right? And then to represent 0 to mean this, 1 to mean that, that is a value label, which you do under values. Okay, and that's actually next. So under values, person ID, we don't need to have values, because it's just going to be a continuous numbering. So in that case we skip, but I'm going to show you on another variable. And then missing, we can leave it the way they are. In this case, columns, as I said, column is normally having the same information as width. And then alignment, I can change the way I want. And then the measure, so in your case, the measure is automatically set to scale. In my case, it was set to nominal because of what the information I had put in. So I can now change it to scale, because it's going to be a continuous range. Input is not so important, so we can stop on this and then go to another variable. Let's have gender. Let's have gender, and then yes, please.
The name is
Person ID.
Person ID. And here you have person ID in the name, and you have also the label. What's the difference?
Oh, okay. So person ID. So when I say person ID, then we have name. We are not talking about the name of the person. So we are defining the properties of this variable. We are not talking about the name of the person. So we haven't come to the name. We are still writing the characteristics or the properties of person ID. It's going to be, okay, person ID. The name of the variable is person ID, not the name of the person. And then the type is going to be numeric. It is going to have width 8, like that, like that. Then we go to the name. Okay, let's go to the name. So the next variable will be name. And then we can change the type. So what is going to be the type in this case? String. So we take string. And the width depends. We don't know we don't know how long it will be. But since we know that there are some long names, then we can put a big one, big enough, maybe 15, or even I can make it 20. And then, of course, there will be no decimals because we don't need that. Then the label is not so important because in any case, you can't forget that this is name. And okay, then the rest, still we can set the columns to be the same as the width, which is 20. And then here, now here I want you to see the difference. We have ordinal. So for string, as you can see, the scale measure is not available when the type is a string. We have only ordinal and then nominal. And then I'm going to tell you the reason. So first of all, scale, those are purely numbers. So if we are going to write names, there's no number in the name casing. So that's why we don't have scale measure for string variables. But then we have two measures which are available to choose from. We have ordinal and then nominal. So, and I think I would request a volunteer to tell us the difference between ordinal and nominal. The mean of gender equaling. So if I used 0 and 1, and I have a mean of 0.15, I know what it means, right? It means 15% of individuals are female. So you see, when you're coding, right from the designing of the questionnaire, you can limit how much time you will need when you are doing the actual cleaning of the data. So many times you find surveys give 1 and 2, but then if I use the 1 and the 2, then if I have a mean of 1.3, it's a mean. It's also a mean, right? What do you understand by 1.3? If I use, let's say, 1 if female, and then a 2 if male, and then I have a mean of 1.3. Can someone easily interpret what it would mean? Maybe not. Of course, you can say that, okay, it's tending towards the females, right? But you can't know for sure. You can't really get a quick understanding of what it is. So that's why when you're coding, then you have to keep in mind, how do I code such that I easily interpret what I get? In this case, if I get 0.15, automatically I know 15% are females. Okay, so let's now do the coding. So this is our dialog box. So we are going to give value labels. We are going to consider these ones, 0 for male and 1 for female. So, okay, so you go to values, and then under value you can put the first value is 0, and then the label we give to that is male, and then you add, and then you specify the next one, 1, and then the label for that is female, and then you add. So after doing that, then you click OK, and then the value label is defined. I want you to know the difference. This is the value label because we are tagging the responses or the values of that variable. So then you click OK, and then the labels are assigned. And then the measure is unknown, so I can change it to scale because no, sorry, not scale. I can change it to nominal, and then the rest can be just fine. Okay, so let's now try to feed in some information. So you can create as many variables as you wish. But for now, let's have these ones, and then we try to feed in some information. Remember, to feed information, we go to the data view. So when we go to the data view, you see that our three variables are already there. So, and also their properties are there. You can see, I think you can clearly see that the variable name is bigger. It has a bigger column because we set it to be equal to 20, and the others were left to be equal to 8. And if you have a variable, a name which is longer than that, you can even go and make it longer. But also you can even change it here, just like you do with Excel by dragging and expanding.
Wait, for gender, we put width, 8, and decimals 2.
No, we forgot to change decimals? No, decimals, we changed the decimals to 0.
0 and
Yeah.
2 for width.
For width, it doesn't matter even if you leave the width to be 8, it will not give 8. It's not 8 figures. It will not fill them up. It will leave them as 1 and a 2 or 0 and a 1. Yeah. But if you wish, you can do that, but automatically the information will be captured correctly. Okay, so.
If you use it to, for example, if you use it to, for field, it means if you want to write the full name of the making.
So, okay, if you use 2 without a label, it will be fine because 0 and 1, right? Maybe you're saying if you put these labels, then it may not display the whole of that word. But for the number itself, it will be displayed. Okay, so let's put in some imaginary numbers so that we see how to do it. So let's say 1 to up to 10. And then you can put in any numbers, any names. I'm just random names, right? Just put in anything, just to have like a small data set of 10 people, and we see how to feed in the information. Just 10 people, any names you can come up with. And then the gender. Okay, so I finished my small data set. And I think one thing is that you may want to move between, so gender has a value label. You may want to move between the 0, 1 and then the male, female. So here, I don't know whether you can see, here, up here, so you can toggle between the labels and the values themselves. Okay, so, okay. And I lost my pointers. I would have pointed, but if you, okay, I think that looks better. I think that's the best way. Yeah, like that I think is fine. Okay, so I can even show you from there. So, oh, you don't have SPSS open. Can you open it and then? Is it that? No. Do you have it installed on your computer? Maybe it's not. Is it? It's not installed, I think. Just. Do you think you have it? Yeah, you have it. Really? Okay, maybe it's coming up. So okay. So you'll be trying. Then along the way you can ask when it's open. So okay. So others, if you have this, you can switch between labels and then the values. So depending on how you want it to be displayed. Okay, so I think so far this is how we manipulate or how we configure the variable view and then the data view. So we have used a simple example of a very short data set of 10 people, but of course you can have, so it's a very short one because it's 10 people and 3 variables. But then you may have, let's say, thousands, even tens of thousands of people, and at the same time you have, let's say, hundreds of variables. For example, if you consider like the NISR survey on financial services, which is called FinScope, it has like 1,200 variables, and then it has so many. I don't even remember how many individuals, but there's so many. But then the variables are 1,200, more than that. So then you need to know how each variable is configured. You need to control how it is managed, how every measure is supposed to be set, so that all the information is captured exactly the way it's supposed to be captured. So for now, I think that's how we are supposed to configure the data view and then the variable view. If you have any question, ask. If not, then I think we could maybe have a break soon, and then we come back and start with the actual data set I wanted to. Is how do you make sure that when you're analyzing, it doesn't influence your results? You can sometimes you can set your analysis so that missing values are not included, or another way is that you can actually change their coding. You can change the coding, let's say 88 into missing in SPSS. So automatically the missing information will not be included in any analysis, whether it is regression or whether it is summary statistics. Then it will be left out automatically. So that's one way to make sure that that missing information doesn't influence your results, by changing the coding into missing. Okay, so let's open the Rwanda macroeconomic indicators, and then we see what is there. We first understand the structure of the data set, then we import it into SPSS, and then we start working. Okay, so this data set is for Rwanda. It's a macroeconomic time series data set. It has a number of variables, a lot of variables. I'm going to explain them for those who may not know, because we are going to use them to study Rwanda's economy. Okay. For those who don't have economics background, it doesn't matter, because studying the economy doesn't necessarily mean you are an economist. Just understanding your country, where you are, the economic structure, dynamics, and the setup. Okay, so if there is anything that you don't understand, you can of course ask and I explain. Anything which is in economic terms, or anything specifically you are not certain about. Okay, so we have the first variable is industry, is agriculture. So this is the value of agriculture. It's in US dollars. Then we have industry. That is the value of the industry sector. In other words, the output, the value of output in the industry sector in dollars. Again, you can see the scientific notation we mentioned, so you know which numbers these are. And then we have manufacturing. This is also the actual value of the manufacturing sector output in dollars. And then we have services. It's the same, the amount of the value of output in the services sector. And then the same applies to investment. It's also in terms of dollars. And then we have FDI net inflow. So FDI net inflow, for those who may not know, or for those who know, can someone explain FDI net inflow? Does anyone understand FDI net inflow? Maybe you can volunteer to explain to those who may not know. FDI net inflow. Can you volunteer? Or may I, or should I? Is there anyone who doesn't know? Okay. Is there anyone who knows? Okay, no one? Okay. First of all, FDI, because we are going to use these variables in our analysis. So first of all, FDI is called the foreign direct investment. So foreign direct investment refers specifically to the investment. So if you are in a particular country, let's say Rwanda, then the foreign direct investments are those investments made by non-Rwandans within Rwanda, within the boundaries of Rwanda. Those are foreign direct investments. If I come from Uganda and I set up a consultancy firm in Rwanda, that is a foreign direct investment. So then we have, so we are saying, first of all, we have an inflow. So I'm trying to break down that word, foreign, FDI, net inflow. So there are three parts. To know FDI, those are investments by foreigners in the country. And then inflow is the money that they bring in due to those investments. And then because there is also what we call foreign direct investment, which is an outflow. If Rwandans if Rwandans invest in another country, that's a foreign direct investment which is flowing out of Rwanda into that country. So it's FDI outflow. So, okay, so we have FDI outflow. So FDI outflow is money invested by nationals of a country abroad. Then we have, so we have two things. We have the FDI, we know the FDI, and then we have the flows, in and out. Then we have only one thing, the difference. So I think from here now, someone is already seeing where FDI net inflow comes from. Who has seen the answer now? So we have FDI outflow, which is investments made by nationals abroad. And then we have FDI outflow, which are investments. FDI inflow is investment by foreigners into the country. And then FDI outflow, those are investments made by nationals of a country abroad. So those are two flows. One brings in, another one takes. And then when we talk of FDI net inflow, now if someone can guess what we mean.
I think you have to divide by number of population.
Not really. Net doesn't mean per capita. Yeah, net is not per capita. Yeah, definitely when it's a net, one has to be minus the other, but not which is which.
The one that goes up minus one. No, the one that goes minus one goes up.
The one that goes,
Minus up.
someone saying out minus in, another one saying in minus out. Both are applicable? Oh, the question is, because I'm explaining this variable FDI net inflow. So, and I started by defining FDI. I explained the inflow and outflow. Now we are trying to understand what will FDI net inflow, because it has three words. FDI, which you know now, then in net, then inflow. Yes, please. In or out? Inflow. Yeah. So because you hear it's you're interested in the inflow, right? Then becoming a net, it means you have to take away the outflow from the inflow, then you get a net inflow. So FDI net inflow is actually the investments foreigners make in a country minus the investments nationals make outside the country. That's FDI net inflow. Okay, so any term which you don't understand, you can let me know and I can explain in simple terms. Then
we have such things in global countries. Now like Rwanda, in these 20 years we have had we have all that. We have got people that invest outside that.
Of course, definitely. That's why this variable is actually here. That's why the variable is here, because the information is actually recorded. Yeah. So this is actual data set, not simulated data. Yeah. So definitely we have Rwandans investing outside the country, and that information is recorded. Of course, sometimes it may not be easy to record everything. Of course, I think that's what you're wondering. How can everything be recorded? So it all comes back to For example, GDP, how do you measure GDP? Means everything that is done must be recorded. But also with a lot of informal activities, sometimes it's not easy to record everything. But at least we have some measure, right? Yeah. Okay. So then we have a variable called a Greek to GDP. A Greek to GDP, I think this is easy to understand. The share of agriculture in GDP. Okay. Then we have industry. So the next one is industry to GDP, the share of the industry sector in GDP. Those are percentages. For example, if the industry sector has value of $10,000 and GDP is $50,000, then that industry to GDP share represents 10,000 divided by 50,000 times 100. So that's the share. And the other variables we have already explained. So basically, this is what we have in our data set. It's a macroeconomic data set. We are going to use it to analyze and understand the structure and the dynamics of Rwanda's economy over time. Okay. Any question? Okay. Yes, please. Sorry?
It is like inquisitive question.
Yes, please.
Because you are in the field of economy. Sometimes I wonder how to calculate the GDP, maybe short. If they take the value, for example, here from agriculture sector, if we take the value of what you produce, that's it, and we monetize it, and we go to the industry like that, and then put the real GDP.
Okay, so yeah. So okay, so someone is wondering GDP. So GDP, what is exactly GDP? Maybe I should start from that. Does anyone have an idea about GDP? Yes, in a layman's language.
Is the value of production that is produced by the inside of the country, in the domestic country, in terms of money, during the period of 1 year.
Okay, so okay, 1 year depending, because you can have quarterly GDP. But basically, you're right. So it's about the monetary value of all goods and services, so goods and services produced within the geographical boundaries of a country. And when I say geographical boundaries, that's what makes it domestic, because there is also what we call gross national product, GNP. So I don't know whether this is beyond what we're supposed to be doing, but I think it's important. So domestic to mean the activities which are taking place within the boundaries of the country. It doesn't matter who is doing that, whether it is nationals or foreigners, but as long as they are doing it within the boundaries of the country. So that's gross domestic product. And then he's asking, how exactly, I think I understand what you're thinking, how exactly do we think about a GDP? What are those? How do we get those numbers, right? So, sorry?
It's the consumption plus spending plus investment minus, I think you're going to do the export minus import.
Consumption plus spending plus investment plus the foreign sector. That's what you mean, exports minus imports, right? Yeah, that's right, the macroeconomic identity. But I think in a layman's language, do you really, assuming I don't know anything about economics, how would I understand how exactly they really get down to those numbers? I think that's his question. And okay, to be precise, so you're right, technically you're right. But maybe in a layman's language, it may not be easy to understand. So to understand GDP, you think about, let's say, NISR and other institutions which are responsible for that. They go down to all levels to know the activities taking place in all geographical areas. If you have a small shop down in the village in Gachenyi, they know how much you produce, if you are producing or if you are selling. If it's a factory in Nyabihu, they know how much is produced, or at least based on the records which are available, right? So all those records are collected and then aggregated into one small number. Can you imagine? So your small business in Nyabihu, my small business in Gachenyi, all of those, what we produce. So everywhere for every production activity, all that information is aggregated together into one single value for that year which you are seeing it there. So you can imagine how much work is done. So that's how GDP is calculated. There are many methods, I think, which we may not go into. There is the output, considering output. There is also considering value added, and then there is also considering expenditure method. So there are many different approaches, but basically they look at the activities taking place and the monetary value of those of the outputs of those activities. That's what is aggregated into one figure at the national level, and in 1 year if it's annual GDP. Okay, so now we know the data set. So then it goes from 2008, 1981, yeah, up to 2019, although some variables are not available for 2019. So now let's have that data in SPSS and then see how we can try to analyze it. Okay, so yes, please.
You are familiar with budget. Since, especially these are the numbers. Now there comes in like 2.5. How comes the data is now going to
Okay, so I'm going to get a volunteer to answer that, because I taught it in the morning. Let me pick one figure, then someone can tell us how it is. Someone is asking, why are we having, let me use industry, column F, 3.2E plus 08. You got it? Yes, you got it now. Okay, so you have already answered yourself. Okay, great. So he saw the answer already. Okay, so that's the scientific representation. Okay. Yes, and of course you can know how much that value is, right? How much is it? A lot of millions. How many millions? Okay, I've already revealed it. 6 zeros? It's 7 zeros, like 32, and then, yeah, so like 320 million, right? Yeah. Okay. So now we can even close our example. We already finished working with it. But if you want to save, just a moment. If you want to save, how do you save? So you go to File, and then Save As, and then find a location and simply save. So just like any other document, as usual. Yeah. Yes, there's a question here.
How can save
Okay, so this is how you can do it. If you want to save it, you go to File and then Save As, and then you follow. Then just like you can save any other document. Yeah. So you can give, when you are saving, of course, you can give it a name which you remember, and then maybe here you can see that the format is SPSS statistics, and the file extension for SPSS data is .sav. So that's why it is in bracket .star.sav. So otherwise, just you don't change the format, just put the name and then proceed. Okay. So in my case, I'm not going to save, but if you need to save, then you give a name and then click save, and it is saved. Okay. And another thing is that SPSS can handle multiple data sets opened at the same time. So you don't have to, so you have separate windows. You don't have to close the software in order to open another one. So even from this one, you see from here, I can go to File, Open, or I can just say Open directly from this icon without closing the one I'm working with. So yeah, so let's try to open. So to open data, we have what we call opening and then importing. There are different terminologies. So when I say import, it's different from open. So opening, you are opening a data set which is already in SPSS format. Then importing, you are getting data from another software into SPSS. So it's a foreign data set introduced into SPSS. So now our target here is to import from Excel. So therefore, we shall go to open. Either go to open directly or to go to File, Open, still it's the same. And then, so if you go to File to open directly, you are directly taken to the location, to the box where you search the location. But if you say File, Open, then you have to specify what you are opening. So you can specify that you're opening data, you can open syntax, you can open output or script. So in this case, we are opening data. So we open data, and then as you can see, automatically or by default, the file extension is .sav. But then how do we change? How do we open Excel? So even when you even when you go to the folder where the Excel file is, if the storage type of the file type is still showing .sav, then this is towards the end of the training. So pick the one which is for Rwanda and then open. Sorry?
You cannot search directly the name of the file.
Of course, you can search and find the name, and then you find it and proceed. Okay, so when you're opening, then you get a dialog box, and you are prompted to say okay. There's nothing much you change there. You just say okay, and then the data set comes into SPSS. So this is how it looks like. So when everyone has brought the data set, when everyone has imported the data set, then we can proceed with some analysis. Does everyone have the data imported? Not yet. Does anyone have any problem importing? You did. You have done? Yes, importing. Okay. Yes, please. Yes. You said you have a question?
It's not easy for us to import.
Do you have it saved somewhere?
On desktop.
So yes, go ahead. If you find that the example dataset is confusing, you can close it and then you start with a fresh file. Okay, you like keep clicking here and then it will keep changing the location, and then when you see the one where you put the data,
We put it on desktop.
you can even change from here, but okay, it has come there, desktop. You can double click it.
Training. Yes. Okay.
It's not there.
Hey, didn't paste.
You didn't save it.
We didn't paste it there.
Ah, okay, you have to. It's empty.
By copy. Right? You must copy paste.
Then you can go back and import. Double click, then the type, file type, type of file. Yeah, it's not SPSS, it's Excel.
We didn't change
Then click it and then first click it to open. Either you double click or you click and click open. And when you get another box, you say OK, and then it comes. Yeah, just say OK. Then it's there. Okay, so. All right, so now I think everyone has the data imported into SPSS. Let's look at some of the tasks we are going to do. We are going to start with data manipulation. So normally before you do analysis, you need to know how to manipulate the variables to get what you want. Sometimes it involves creating new variables. Sometimes it involves modifying the variables which are existing. So let's start with one of the important tasks which a data analyst normally does, to create variables. So many times you get, let's say, secondary data sets, and they are not, of course, secondary data sets cannot exactly exist in the format that you want. Always there will be something that you need to change in order to have the data set prepared in the way that you want to use it for your particular analysis. Because when I'm preparing the data set, I'm doing it for my own. I feel like it's appropriate for the type of work I want to analyze. But someone else may want a variable measured differently, may want some new variables, like different ways of coding. So let's see how we can make some manipulations. And then the first manipulation, the first manipulation we can think of is to create categorical variables. So let's see how to create categorical variables. Okay, so what are some of the categorical variables that we can create? So let's start with the simple one. We start with the simplest one. Let's create a variable which is based on the variable year. So I want to have a variable called post 2010. I think you can imagine how it's going to be, right? Post 2010. It's going to be, remember that categorical variables have categories. They don't have a continuous range of values. But I can use a continuous variable like year. It's continuous. Then I use its values to create a categorical variable. In this case, the categorical variable you want has two values. In other words, it's called a dummy variable. Again, if there's something you don't understand in terms of data language, you let me know. So a categorical variable has categories, and if those categories are two, then that variable is dummy or binary. So if you forget, you can ask me to clarify, but that's just basically the definition. So I want post 2010 to be like this. I want it to be equal to 1 if the year is greater than 2010. And then I want it to be equal to 0 otherwise. So in the example I gave, previously regarding gender, we were just entering data, right? We're not creating. But now, we're not creating from an existing variable. So now we are creating from an existing variable. So how do we create a variable? We are going to have something like this. Remember, when you're creating variables, especially when you have existing variables and you want to use them to create new ones. So you are thinking about this, I'm calling it the parent variable. You're thinking about this, the original variable, how it is structured. You're thinking about which rule is going to transform it into something that you want in order to have this new variable that you want. So you have the target, and then you have the target variable which is going to give you the information, and then you have the rule, and then you have the outcome which you want. So normally when you are working on a project, you have to think about how exactly do you want the variable to come out. So it's going to be like this. You want it to be like this. You want a variable year, and then you have a variable post 2010, and so always when I'm creating variables, I like having like when I'm doing data cleaning analysis, I always have papers. I write a lot of things so that I plan before I do some manipulation. I have to plan how exactly is it going to come out. If it's a graph, I have to plot it and see how is it going to come out. Then I start working on it depending on how I want it to be. So I want, for example, 2008, 2009, 2010. Something like that, up to 2019. So I want, if the variable year, which I already have, is below 2010, I'm going to have far between the years before 2010 and the years after 2010. So I'm not just creating a variable to have to be in my data set, but I actually want to see how the situation of the country was before 2010, and then how it is on average after 2010. So, yes, please.
So I think for me, there's a confusion with the first I understand. But when you define the one, if the year is
You understand? You are wondering what exactly is this one if like.
No. That's 2010. I think for me, when there is no greater or less than, I think 2010 should be. Where should we put 2010?
So this one, if it is greater or equal, it means even 2010 is included in the one category. Because greater or equal starts from 2010 itself. When it is equal to 2010, it is equal to 1. Even when it is greater than 2010, still it is equal to 1. In that, if that was the case, then 2010 will also be equal to 1, right? Okay. Let me break it down. So if I say, yeah, it's greater or equal to 2010, right? You assign a value of 1, assuming it was like that, equal to 1. You start with 2010. Is the year equal to 2010? Yes. Then give post 2010 equal to 1. Also come back, there is also another one. Even beyond that, all values beyond that should be equal to 1. But in this case, this is called strictly greater. This is weakly greater in a statistical language. So this is strictly greater than 2010. It doesn't include 2010 itself. Yeah. Okay, so I was adding that always you need to think of, like, there are like 3 things. What do I want to do? Why do I have to do it? And then the last one is how to do it. Because how to do it sometimes it may even be the easiest, but then why and what exactly. So we have known the reason why we want to do this, and now we want to see how to do it. Can anyone suggest how to do it?
We go back to the variable u and
Sorry?
we go back to the variable u.
We go to variable view and define it. That's fine, but we can actually do it without defining it, because by the fact that we are making it, we are actually defining it, right? So it's going to be different from working from scratch, building something that is not there. Here we have, for example, we are not going to enter any data there. So we are not going to do anything with the data view. So we are just going to do one step, defining the variable itself from existing information. So therefore, we shall not go to define, but later after defining it, we can change some of its properties. Because if we go to define, actually when we go to define, it means that we have to come back. Every time you define a variable, you have to come back and feed it with information. So now, if this information, so are you going to feed in all the zeros and all the ones? Of course you can do that, right? Manually checking 2008 0, 2009 0. It's possible, but of course it takes a lot of time, right? So you do it automatically by creating a new variable. Okay, so this is how we do it. We go to transform. Yeah, so transform and then record in 2 different variables. So maybe I first explain what transform means. Those of you who know how to do it, you can even go ahead and do it. Those of you who don't know, I can show you step by step what is transform. So, okay, so those of you who know how to do it, go ahead and do it and check how many observations belong to the 1 category and how many belong to the 0 category. So that's your separate assignment. And even you can do some analysis checking the variables between before and after. Okay, so we go to transform and then record into different variables. First of all, transform. So transform is a function of SPSS which helps you to make modifications to variables. So we are going to transform a variable to have what we want. So which variable do we want to transform? It's year. And which variable do we want? Post 2010. And then the question is, should we, let me go back briefly. The question is, should we change this variable and replace it with this one? In other words, instead of having these years like everywhere within this same variable, should we just replace and have 000111? Of course, it means we are going to lose the original information, right? So if you go to file, if you go to transform, record into same variables, it means you're going to replace the information in the year variable with the information that you want, which is not what you want. You want to keep your original information. Even it helps you to check, because after creating, then you can check. You can go and open the data and see, okay, does it correspond? Sometimes you create something and you make a mistake, but then the mistake is accepted because SPSS is just a tool. What you give is what is done. Sometimes what you do doesn't come out the way you want because of maybe you made some mistake. So you have to keep the original and then you compare with what you have got. So that's why we are saying transform and then record into different variables so that you don't replace the original one. Okay, so I open mine and then we do together. So we go to transform and then record into different variables. Okay, so when we reach there, those of you who have used SPSS before, you know how to proceed. But those of you who don't know, you need to think of what is the target variable. So the target variable is the year, and then how do we make it the target one? By clicking on it. It's already selected, it's the first one. If it wasn't selected, we'll just select it from the list. So click it and then click here, this forward arrow to add it into the box. So this is our target variable. Okay, so step by step, if you are, don't get lost as we proceed. If you're lost, ask so that we can pick you up before we finish it up. So we have taken here is the target variable, and here you can see the output. You have the output variable. So the output variable is post 2010, the one that we want to create out of the target variable. Yeah. So let's have post 2010, and as you can see, you have an option to put the label if you want. It's the same label which you can define under the variable view window. Yes, a question there. You can't put a space in the name. You can't. If you want a space, if you want more than one word, you can use an underscore. So it's a rule, you can't use spaces. Yes, please. Do you have SPSS on your computer? Oh, you have. So open it and then go to file, open, then you find where it is located. So it would, sometimes SPSS takes long to open sometimes, so you have to wait. When it opens, you go to file, then open, then you change the file type from SFV to Excel, and then you look for where it is located. Then you look for where this one is located, and then you find it and click open, and it opens. Yeah. If you have any issue, you can you have to wait for it to finish. It's going to bring something, then you close it, and then, okay, it hasn't brought it, so just go to File, Open. No, I think it's, I saw it's like it was there. Yeah, you save it somewhere, and then you look for it where it is located, and then you import it. Okay, so problem. Okay, is it general or should I come there? Is it general problem? Can you ask, please? The difference. You're wondering about the difference. Okay, I explained the difference between record in two same variables and record in two different variables. I saw someone who understood it very well. Who remembers? Who can repeat for him? Okay, please.
You said when you want to record them into the same variable, it means you are going to replace the existing variable which were here, different years, represent on what you are going to transform. But if you say to keep or remain with your existing data, which was in the column of year, like 2008, 9, 10, and so on, and then you will also have the new one, what you are going to create.
Is it clear?
Yeah.
Sorry? Clear? Is it? Okay. Okay. So, yeah, your explanation is right. So maybe let me give him also a chance to add to make it more clear, maybe for them to understand.
We can say that when you are going to create category variable, so we have already existing information that we are going to use. So we are going to make a category for our example, in the year, instead of using every year, we are going to make it into two categories. They are post 2010 and below 2010. So for all data, for all the years, which is above 2010, instead of using year, we are going to use one for both years which is above 2010. And those which are below 2010, we are going to use 0. So to do that, we have to transform our data. There are two types on we are going to transform either into different variables or into the same variables. We use the same variables when you are going to replace our existing data. Those columns of the year, we are going to replace it with those variables, 1 or 0. But when we use different variables, they are still there. We are going to use 1 and 0, but the year also, the column there will still there. Instead of replacing it. That's what can say.
Yeah, you're right. You want to add to that? Sorry. Before the question is cleared, before we go to the next, I want to know whether it is understood. You understood? Okay. So then you have a question.
That is our data. We are going to manipulate them. We have here the variable G. What is the main reason why we cannot manipulate them in variable G and we go to transform?
Okay, yeah, that's good. So that's actually what she also asked that. She thought we could go to variable view. As I said, yes, you can go to variable view if you wish, but then I'm going to show you how this is the best, right? If you go to variable view and you create, like with the same one we did in the morning, right? Create a name, let's say post 2010. Then, remember whatever you define in variable view, you have to enter data in the data view. So then to feed in these numbers 0, 1, 0, 1, 0, 1. So, okay, this data set is not so big, right? There are like 37 rows. But, of course, sometimes you have a very big data set, a very big one. So how do you come and feed in those zeros? So for now, this one is easy. Where you see here, you can just put in 0 for 2008, 9, 10, and 1 for 2011 up to 2019. That one is easy. So you can, it's possible. It's not a must to go to transform, but it's a matter of convenience and efficiency. So when you are doing data analysis, you're always looking for the best and the quickest way to do something, right? Because you have no time. Most times you're working with deadlines. So you can't feed in 0, 0, 0, 0, 0, 0. Like you can't work manually when you have another way to work automatically. Yeah, but it's possible to do that if you have the time. You can even try it out. It will be exactly the same. Okay, so, yes, please. Okay. So now we are going to create a variable. So go to transform, and you record into different variables. No, different. Record into different. When you put same, yeah, when you go into record into same, it means that the variable is going to be replaced. The years are going to be replaced with those codes 0, 0, 0, 1, 1, 1. But you don't need to replace the information. You need to create a new variable. Yeah. So then you choose this one and throw it there. Yeah, that's where we are. Okay. I'm assuming some of you have finished it, but for those of you who don't know how to do it, let's continue. Give it a name here. It's post 2010. Here you want, if you want a label here, of course you would put, for example, I like using these labels. 1, if, yeah. So you see this label. It's a short label, but it helps me to know. It helps me to know what it is. 1 if year greater than 2010, meaning, so I have in mind that, okay, because with the dummy variable, you have the 0 and then you have the 1. So if I have 1 if year is greater than 2010, then in my mind, I know not only what the variable is, but I know that the 1 category is the case where the year is greater than 2010, and of course I know that the opposite is equal to 0. So I could use this as my label, and when I see this, I know that I know how exactly the values also are supposed to be. So you can put the label if you want. If you don't want, you can just ignore. Sorry? For the label, you can separate text. Yeah. It's just a sentence. You can even add a sentence, a long sentence. Yeah. So, but of course, when you add a long sentence, sometimes when a variable has a label and use it, for example, in a graph, then the label may appear. So if you use a very long label, then still you have a lot of words in your table and graphs. Okay, so what next? What next is that we have to click here old and new values, because we have to get the rule which will tell us which values to assign to which category. So to do that, we go to old and new values. Now here, this is where we have to be very careful on how exactly we define these variables. So we want to have post 2010 for years which are beyond 2010. It's going to be equal to, they are going to be assigned a value of 1, and for those which are below 2010, including 2010, so 2010 and below, we are going to give a value of 0. So how do we do that? So here we have we have, these are rules that help us to define these values. So the first rule, okay, before that we first put in the value, and then, so we can decide the value here. If you know a specific value from the variable year, then you have to specify the value here, and then you specify the corresponding value you want to be in the new variable. But of course here the years, like, okay, I'll give you an example. You can say, if you have, let's say 4 years, let's say few, and you want to just change those few to add the corresponding numbers. So you can say you are changing, for example, 2 to be equal to 1, 3 to be equal to 5. So those are, that's like one-on-one modification when you know a specific value which you want to change into another value. Like for example, someone mentioned, if we have like those numbers, negative 999, this is how we would specify, because you know the value you have and you know which value you want it to be. Okay, so in my example of 99 for years of schooling, I would say 99, and then I would say, okay, if 99 represents no formal education, I can just make it 0, because 0 is more appropriate to show no formal education. Okay, so that's that case. But we are not interested in values. We are instead interested in a range of values. So, how do we specify a range of values? Here you see we have, okay, we have a range, then we have range. So this range, the first one, range between something and something. So if you click on it, you find that you have between some value and some other value. So then we have also another option, which is also a range. So the second option, which is range, specifies lowest value, it specifies range lowest through value. What does it mean? Lowest through value, meaning, it means that look into this variable. Remember, we are looking into this variable we have specified. So look into this variable, and then from whichever value is the lowest up to the value that you're going to specify, then you assign a particular value. You understand? So lowest through value. Lowest through value means from the lowest up to the value that you're going to specify, then you give a value that you want it to represent. Yeah, exactly.
The
2010, yeah. Yeah, exactly. So range, lowest through value. In this case, that value they are talking about is 2010. From the lowest to 2010, we give a value of 0. Yeah. So range, lowest through value. So you don't need to know the lowest, you just need to know the cutoff point. So the cutoff point here is 2010. He mentioned value through highest. So if you say 2019 through highest, it will be 2019 only. Okay. I hear 2013, 2011. 2012. If you say 2012, where will you put? Okay, 2011, 2011, and then you have a different answer? Yeah, have you seen the first part? The question is, how do we record the next one? So all other values. Okay, let me write this. Let me write here so that we can see. So we can say both of you are right. You can say all other values. I'm going to come back to this and ask a question. In this case, we are lucky that we can say all other values, and then someone is going to see where it may not apply. All other values, and then range value through highest, and then set the value, which is the minimum value. In this case, it will start from 2011. So still this will be fine. Then you assign a value of 1 for that. Then you can also say values, all other values, because you have specified from 2008 to, from the lowest up to 2010, then all others are actually these ones. Because we have only 2 values. So this one may not apply when we still have other values to specify, other categories. So in this case, it works because we have only 2. When we define the first part, then the remaining, all others can go into all others. But I'm going to give you another exercise, an exercise to define one which has 3 categories, so that you can see. Actually, I'm going to give you 2, 1 for 2 and then 1 for 3. Yeah. So for now, we are lucky. This works. Okay, so let me take all other values. In this case, I give a value of 1, and then I click add. So you see automatically it says else. So all others which are not the previous one are given this value. And then what next? Click continue. Click continue. As you can see, there's something still missing. You know why? How do you know that something is still missing? OK is not active, right? Yes. You got lost? Oh, where exactly did you get lost? Oh, sorry, what? Okay, let me come there and check. Did you understand how this was done? Yes. Okay. So now all other values, meaning all others which are not 2010 and below, will be given a value of 1. So the value is supposed to be put here. It's 1. And then you click add and then click continue. That's where we are. Okay, so as you can see, active is, OK is not active yet. Sorry? Don't put label. Don't put label. This label is supposed to be for the variable. So 1 is not, it's not referring to that. So just okay, yeah. First remove that. Transform. Record in 2 different variables. Take here. Then put the name post 2010, but don't put the label. The label is supposed to be the variable label, not post 2010. 2010 to 2010. Yeah. Then okay. Then which version do you have? Which is Spss version? Okay. So you can click order new values. Yeah, you're supposed to do it from there actually. You start assigning. So we started with that one. Give it value of 0, and then starting from lowest through 2010.
I did not save the previous.
No, you are still working. You do this. The other one is just the name of the variable. Here you are defining the values which are supposed to go into that variable.
You have the memory of this one.
Yeah. Everything is going to be kept until you click the final OK. Yeah. No, you haven't finished this one. It's equal to 0. And you haven't put the value. You see lowest through high through value. That value should be specified 2010. 2010. So you can add. Then you go back. So all others are equal to 1. All others means from 2011 and up to the highest. Yeah, those ones are equal to 1, and then you add that, and then you continue. That's where we are. Yeah. So, as you can see, OK is not active, so you cannot click OK to continue. There's something missing still. Can someone remember? Does someone know what is missing? Does someone know what is missing so that we get OK to be active and then we finalize the transformation? Something missing?
Yeah.
Sorry? For you it's active. Okay. I think you did something before us. Yeah. Okay, so I think many people it's not active, right? So it's remaining for one final confirmation to change. You did that, I know. That's why it's active. You did that. You changed it. So you clicked change. So you click change to, so now you have been defining, but you haven't confirmed or authorized that transformation to happen. So you say change, and then that is, so the rule is implemented. Then the last one is to say OK, and then you have the actual values printed in the data set. So you say OK, and then it's done. Yes, please.
Change.
Where did I find the change? First you continue, then change is there. Don't put the, oh, okay, the label is fine. Yeah, it's fine, yeah. Okay, so click change is there. Okay, so now the variable is created. So the question is, where is it? And how is it supposed to be presented? So, okay, so when you go to the variable view, you see it's the last variable under the list. And then just a moment. And then when you go to data view, or still you go to the end of the data set, you see the problem which is there. So we have 0.00. So we have decimals, right? 2 decimals. And we don't want decimals. We want to have 0 and 1, because these are just dummy. This is a dummy variable. So we have to make some changes. We go to the variable view and change the decimals to 0 and 1. We change the decimals to 1, to 0, and then it's done. Then the dummy variable is the way we want it to be. When you go to variable view, you change the decimals to 0. There were 2. Automatically, when you make a variable, it gets 2 decimal places like that. And this is how it was looking in the data view. But then you don't want 0.00 and 1.00. We want 0 and 1, as simple as that. So remember to change the properties. So having decimals, that's a property of a variable. So to change that property from having 2 decimals to having 0, you do that from the variable view window. So go to variable view and then go under post 2010. You look for it. It's at the end of the list. The decimals are 2. You change them to 0, and then that's done. When you go to data view, then it's exactly the way you want it to be. And then still there is a question. We have 0 and 1. We can still do better than that. What else can we do to make things better? We can add some labels, the value labels. Yes, please.
We can turn back to the variable.
You want me to go to variable view? What you do from the variable view is that You see this, you see your variable post 2010. It has 2 decimals, right? Do you see the column of decimals? There are 2. And if you go to data view, you can see that it's 0.00 and 1.00. So we don't want those decimals. We want 0. It's either 0 or 1. Okay. Okay, good. So, all right. So I think everyone has created that dummy variable. But now the question is, we are seeing 0, 1, 0, 1. But then how can we make it? I want it to have something like this. Let's call them, so 0, I want it to be, let's say, 2010 and earlier. And then I have 1 to be later than 2010. So, this is what I want to see in my data set. How do I do that? I think I'm assuming that at this time now everyone knows. Am I wrong to assume? I think, I'm right. I think I'm right. Everyone knows how to do that, right? Yes. Yeah. So, yeah, so you're right. Only that you asked, actually. You know the answer, only that you asked. You answered in a question form, but it's right. So you go to variable view and then do the value label assignment. Has anyone forgotten? So can you do that? Can everyone do that? These are the value labels that I want you to assign. One thing you didn't ask, yes, please.
Now, since after having that, we now have something that is very different from what we had previously. And this is what we have. But what do I do? Do I have to again save it as another file?
You mean, okay, after modifying that. Okay, so I think this can be a general question. So someone is wondering, okay, we have added something. Okay, we have modified our data now. It's different from what we had originally. We have added a new variable. Of course, we are also going to do a lot of things in this data set. So, of course, you can just go to File, Save As, and then save it as let's give it a different name. Always remember, don't save and replace. So save and give it a different name, which is a modified one. So yeah, it's the same way. Go to File and then Save As and find where to save it. Give it a name which is different from the original one. Did I see a question there? Yes, please.
Well, that's what we are going to do. Because there is zero with 2010. Means from 2010.
And then other years below, yeah. Actually, the 0 is already there. The 0 and 1, these values are already there. We are only adding labels to them. Yeah, they are already there. We just add labels to them. Exactly. Yeah. Yes. So the variable is already there. It's posted 2010. Just going to change the labels only. Then I'm going to give some kind of brief task. Yes, please.
is the question having
Sorry? With that one, have you done it yet? You're supposed to add a label. You're supposed to add a label so that instead of seeing 01, you see 2010 and earlier, then later than 2010. You know how to do that from variable view? You know? So this variable is already there. So under values, that's where we define labels, value labels. So click under values on this. Yeah. Then you remember how we did it. So one, the 0 is supposed to represent. So you put a label, that label, 2010 and earlier. Then you add and then you click the next. This label is not representing exactly what's supposed to be. 2010 and earlier. It's not only equal to 2010, it's equal to 2010 and earlier. Just add start with the 0. Yeah, 0. And then put 2010 and earlier. 2010 and earlier. And yeah, just words. Yeah. 2010 and earlier. Then you add. Then you go to the next. You add that. Then you go to the next. The second one is 1. Later than 2010. Okay, has everyone added the labels? Those of you who haven't, you can just follow what I'm doing. So we have the label, we have the variable post 2010. We go to the variable view window. Under values, we click to add. So the value 0 is going to represent 2010 and earlier. So we add, then the value 1 is going to represent later than 2010. And then we add, and then we say okay. So now when we go to the data view, we can still change the way it appears. So we have 2010 and earlier, and then we have later than 2010. And we can still change and see numbers 0 and 1, or we can see the labels depending on what we want. Sorry? We have to choose?
Yes, I have to change it, but it's not appeared on the data.
You have added the labels?
Yes.
Okay. So this is where you change from. Sorry? Let me check.
But I have changed the value. On this. It's okay. Then, so when I go to data view,
You have to change here.
oh,
Yeah.
okay.
Yeah. So then when you want to go back, still you have to change there.
Okay.
So from alphabet to number, from number to alphabet.
Okay.
Yes, please.
We are going to add something like this. This one. Like this one. Which should be here. Which will be there. And we will start from transform.
So if you want to add
That one.
the label,
Yes.
you go to the variable is already there. You go to variable view.
And then you go to it.
Remember, this is a value label. So under values, value labels are put. No, for this one, it's only this variable. So under values. So that's where you define. So 0 is supposed to represent that. And then 1 and earlier. Then you click add and go to the next. Yes, please. Yeah. So remember always value labels. We have value labels and variable labels. So variable labels are put under labels. Variable labels, value labels are put under values. Both of them are done from the variable view window. Okay. So in this case, you have created the variable post 2010. Then you need to change the value labels. You need to add value labels. So under values, so go to post 2010, and then follow the column of values, and then define those labels. Yeah. So 0 is supposed to represent that 2010 and earlier. So you put the value 0, then you put the label 2010 and earlier, and then you click add, and then you also define the one for later than 2010. Here is fine. So that is 20. That for you have done it already. Okay. So yes, please. You did it. Then to check to see the changes, you have to go to the data view.
What does it signify this? Because I'm confused now.
What does it?
The word value comes back many times. And I'm somehow confused. This column of values.
Okay.
What does it signify?
Okay. So I think I'm going to explain that as a general clarification. But first of all, you can do it, and then let me go to data view and I see whether yes, you just go to the end and I see whether it's there. Yes, it's there. And if you want to change to values, to value labels, you go there, click there. Yeah. Okay. So, there's a question which I think may be general here. Someone is still wondering, but what are values? What are values? So values under variable view window, we have two important things. I don't mean others are not important. Two related sets of information. We have labels. So this is like clarification, not. So we have labels, and then we have values. So someone is wondering, what I'm not understanding actually. We have labels, we have values. So what are they? So labels, these are variable labels. So they are called variable labels. So they are descriptions which tell you what the variable actually is, not what it contains. Okay? It's like describing the outer shell. If I tell you to describe me, you would say I was putting on a blue trouser, a coat. That's a description. But then if I tell you to describe my content, maybe then you will say, maybe he knows econometrics. That's the content of me, right? Then the outer part is how I appear. The inner content is what I have inside. So the same applies to the variable. You have a variable, it's like a shell, an outer shell. So the variable name is given a description. So it shows, so these are variable labels. They show descriptions of what variables are. And then we have values. So these are value labels. So they are value labels. So they tag specific values. Okay? They tag specific values of a variable. So these ones tag responses. In other words, the content of a particular variable is what is tagged or what is described under value labels. So those are the values when you go to the variable view window. So, and I think so to have an example or to understand better. So if I have a variable like schooling, which I've used many times, if I have a variable like schooling, the variable name is schooling, right? So then I think let me even do it here so that you get really a good understanding of these things. So illustration of so I have a variable called schooling. It's the variable name. Then I have a variable label. The variable label is going to help me to describe what schooling is supposed to be all about. Sorry?
Like years of education.
Yeah, for example, writing like years of education, or if it is categories, it will be like level of education. Still both of them about schooling, but I'll specify exactly what I'm trying to talk about when I say schooling. So in this case, let's use, in order to match with what I want to put, let me use levels. So let's say level of education. So that will be the description to tell me what I mean by schooling. So this is the variable is schooling. Its description or the definition of this variable is level of education. In other words, when I say schooling, I mean level of education. This is a variable label. And under SPSS, the variable view window, you do that under labels. Okay? Then, how about the values? The values are responses. So, we have, let's say we have these, we have, let's say 0. Let's say we have 0, we have 1, we have 2, 3, and 4. So those are the values. This variable is just a container of information, but the actual information we want is actually this one. So these are the values. So when you give a description to this variable, it has nothing to do with what is contained. What is contained can also be tagged separately using what we call a value label. Describing the variable itself, that's a variable label. Tagging the values which are contained, that's a value label. Another difference here, the variable label, you find it under labels in the variable view window. The value label, you find it under values. Okay? So then we have like let's say no formal education, and then maybe primary, secondary. So now you can see the value, the difference between variable label, which is a definition of the variable. It's like a further definition of what the variable is. Then value label is tagging what each particular value represents. So that's the difference. And then in terms of how to do it, this variable label, you do it from labels, and then the value label you did from values. Both of them are found under the variable view window of SPSS. Sorry? Variable label is the one which is under labels. And then value label is the one which is under values. Yeah. That's a value label. Yeah. Okay. I'm hoping now it's fine. And I think everyone has finished that assignment. I'm not sure when you are supposed to have a lunch break. I don't know. I even don't know whether it's ready. I don't know who is in charge, but are you hungry already, or should we push on? Sorry? You're already hungry. Okay, so I'm not sure whether it's ready, but we can have a, yeah, okay, thanks. So it's going to check. I know you must be hungry already. So let's be just trying to have a recap. I'm going to put for you a short assignment. It's short, but to make sure that I see how you have grasped this information. And then after the break, we can go through it briefly, and then we can go ahead with. So the variables we are creating, we are actually going to use them for analysis. So don't skip something and say, okay, I'll go to the next. So normally my trainings are, what I do in my trainings are sequential, and they are following up. So if you miss one step, then you might find yourself lost in another step. So these variables, this variable we shall need it somewhere, and also I'm going to add some more which you can do maybe after the lunch break. So this is, I want, Okay, so that's going to be the brief assignment. I've been informed that your lunch is ready. So this is going to be the brief assignment that you're going to do after lunch. And then these variables, we're actually going to use them for the analysis that we're going to do after lunch. And how long do you want the lunch break to be? 30 minutes? Okay. Will they be enough for you? Personally, if I have no problem with 30 minutes, depending on how easy it is for you to finish. We used, I think, like 30 minutes for the break, almost 30. So I think to be realistic, you will not be done in 30 minutes.
Well, let's say 30 minutes and then it becomes 45.
So maybe, yeah, so I'm assuming that 45 may be easier for you. For me, 30 is fine, but I think for you, 45 will be fine. So that means we are breaking off at exactly 2 and then coming back at 2:45. Yes, please. The last question, this one. It's not clear. Create a categorical variable. This is the name of the variable, and these are the rules you're supposed to follow. You see that it's dependent on GDP growth according to these 3 rules. And then after that, you have to add these 3 value labels, like exactly like this, the way they are. Now you are free to go for lunch. It's already lunch time for those who want to go. Because now you don't have a chance to do all the others. Everything has to be defined the way it's supposed to be. So from lowest to 5, then you need to know where the next range picks up from. Should it pick up from 5 or from 5 point something? Because we have decimal places this time, we have points. So you need to know where the middle range, the medium growth rate picks up from. So it should be between 5 and 7, and between 5 and 10. So, okay, let me see how I define it. So as you can see, the category is 1 if GDP growth is less than 5. So it's very clear that 5 is not included in the first range. So you have to specify. It's not less or equal. So it's not less or equal. Remember that. So if I want something less than 5, then I have to pick lowest through 4.9. You understand? Lowest through 4.9, so that the next one will pick up from 5 to 10, and then the next one, the final one, will include all others. Then remember also the medium growth is a range, so you can't have lowest to highest, or lowest through value or value through highest. or you can't even have all others. For the medium growth, you have to specify two numbers, the lower and then the upper. If the upper one for the first category was 4.9, then the next should pick up from exactly 5.0, and then up to 10. And then the third one is easy, all others. Don't forget to remove the decimals. They are not necessary, and then that's all. Everyone has finished. Is it? You have some issues? If you have issues, don't fear to say I have issues. Whether as a group or as an individual, you can call me and we sort out the issues. Okay, who has finished? Who has finished? I think it's not easy to have to have a bigger view than this. I don't think it's possible to have it may not be possible to have a bigger view than that. But as long as you are following on your computer, you can have an idea how mine looks like, and then you compare with what you have. Okay, who has not finished? I asked you who has finished. I saw I think one person. You are finished. Okay, who else has finished? Okay, yes, I checked your work, you are finished. Have you finished? Not yet. Okay, so let's wait a little bit for those who are still finishing. If you have issues, you can let me know. So when you finish, you can be maybe playing around with some of the variables, and those who have not finished, you can continue working. Then when you finish, then you let us know. Yes, please. Oh, okay. Okay, let me check how you. But you have done it actually. Oh, you haven't. Yeah, it's okay. No. No, just this one, you take it back. Take it back. Yeah, yes. Yeah, the next is the name. You remember the name, how you manufacture? It's actually small letters, all of them are small letters. Hi, H-I. No, H-I. Manufacture. It doesn't matter whether you put a label or not. That is the label for the variable. Then you have to put the values. Yes, old and the new values. Always through value. So that's where you had the question, right?
Yes.
So that value is going to be 7. Anything between the lowest up to 7 is going to take the value of 0, And then 7 and above will take value of 1.
And then once you go to the high or
So all others will be fine because there are only 2 categories. There's nothing else left. No. All others, because there are only 2 values. So all others will be easy. You don't have to specify anything. Yeah. Yes. And then from there you go to the variable view window and then set the label. No, you were trying to close. Don't close. Just remove it. Yeah. Then you go to. No, don't close the. Yeah. Then you go here and you change the decimals and then you put the labels. Yeah. Labels as decimals are 0 and then you add the labels. Yeah. Yeah, exactly the way I suggested, like this. Money to GDP less than 7, money to GDP greater than 7. Yeah. Of course, greater or equal, but in terms of notation, in terms of words, this one will be fine. Any progress there? No. Feel free to ask, by the way. This is an interactive session. This is not an exam, by the way. This is not an exam. It's not a test even. It's practice. You can ask any time. You need to know the process. Okay, but you need to show me what you did first so that I know where to start from. Which variable is that? Post 7? What's that? You have to, actually, even when it comes to the test, please make sure if I specify a name, if I specify a variable name, I want us to be uniform, right? So this is the name. The other one I'm doing post 2010 is because post means after, and then there is 2010, so after 2010. But this one post 7 doesn't mean there's nothing like after 7, right? So the name is high manufacture, and then the rules. These are the rules. These are the rules. Yes, please.
I have a question regarding that one eviction plan quickly.
Okay.
How do you have the time to go and have hotels
Those are numeric and they're going to be stored as a scale. These ones. These are numeric. Multiple responses. Now that's I think what I'll do, I'll give you a better response when it comes to like qualitative, but to give you a quick answer with multiple responses, you have to be careful, not just because now here you have 6, 3, 5, like it doesn't make sense when you are analyzing. In terms of seeing, you can see someone has 3 answers, but you can say, for example, if for example there are 3 problems, right? What is the biggest problem? You can make that a variable. What's the second biggest problem? What is the third biggest problem, right? So you don't have to have everything like in one, and you can split them into separate variables for easy access. Yeah. Then you work with these ones which are split. Yeah, it's easier. This one I can just give you just an idea how things are, but then in terms of analysis, this is the one you use. Yeah. almost there. There yet? You're there? Okay. Any progress? If you get lost, you let me know. Okay, let's check it. Can you go to variable view? Money to GDP, yes.
I will show you how I did it. I don't know whether it went through.
You actually did a different name.
Yeah, I created a different name.
Okay, so, but you see, okay, the challenge you'll have that when we start working, we shall be using the exact variables that we have used, and then you may get lost. So
how do I go about it?
So you can rename this. You can change it there. It's supposed to be high manufacture. High manufacture, but let me first check the actual content. 0 less than 7, greater than 7. Okay. And also you can go to the data view to check. Okay, manufacturing, the GDP, like this one, greater than 7, less than 7.
This thing was also
less than 7, yeah. So, yeah, that's fine.
See the way I did it. And you will help me if we have to go back to the other steps. I did like this. For example, we are on this one. I had to create another. I inserted a variable, so I immediately typed. This is like if I can have 1,000 variables, I cannot manage. So I went on saying, for example, here greater than 7, this is greater than, the value is greater than 7. 1.
Oh, no, that takes a lot of time.
That's why I was saying, because I didn't easily remember the way it was like. So I came here, transformed it, told it to different variables.
You first reset. Yeah.
This one reset.
And it takes it's still money, this money to GDP. No, it's supposed to be money to GDP is the one you're supposed to base on. Then you the name is high manufacture.
So this is
the new one. Finished? Not yet. You lost? Okay, I'll come there. Now that's the label of the label of the variable. If you want to add a description for it, it's okay, but it's not a must.
so this is okay now.
Yeah, that's fine for now. You can go to old and new values, then you define.
Then define it now. That's where
You have somewhere from 0 to 7, so you have range lowest through 7, so you can specify. No, you have to put 7. 7 will be the cutoff point for that value. Yeah, and it's the corresponding value is supposed to be 0, because remember 0, if it's below 7 and below is supposed to be 0. Then it's 7 and more than 7 is all others. No, you can just say all others. All others mean which is not this. All others will be 1, and then you are yes. You know why all others? Because you started by defining from 0 to 1. I mean from 0 to 7. Then all others means more than 7.
Oh, greater than 7.
Yeah, so even if you start like this, even if you start by defining 1, more than 7, like 7, let's say 7.1 up to the highest, then all others, then that will be the other one. Then you continue. Then you change, and then it's done. Yeah, yeah. And then you go to the variable view window to give it a label. You remember how to assign labels? The variable view window. Then you assign them, you change the decimals to 0. And then labels.
This is it. So to check it, I mean to change.
Yes, you need to change the decimals. Don't make sense in the.
Then I need to.
Then you have to specify like this. This is how you specify. Money to GDP less than 7, that is for 0 category. Then money to GDP greater than 7 for the 1 category. And then that's all. So do you have a question there? Is everything moving well? You're lost. Come that side. Yes, please.
On this category of putting 5 between 5 and 10.
How to put?
May I add from just a second?
Can you go to? Oh, you have already put it.
This is the first.
You're asking about the second.
Where we put between 5 and 10.
Oh, actually, just a moment. Just go back to this variable view and show you some problem. This is a problem actually, because you are saying 1 if GDP growth is less than 5. So this is not a dummy variable. It has a 3 categories. So I cannot give it a label which is corresponding to only one category. You know why? For the case of dummy variable, I used 1 if this is that, because I know that the other one is only one other category which is left out. So in this case, you can't say 1 if GDP growth is less than 5, because then how about the other 2? The remaining ones are 2. So it's not the. So you should use something else to describe it, not this. Now for this one, it's fine because it's dummy. When there's one category and then there is another category. So when you see the first one, you know that automatically the other one is the one which is left out. But when there are 3, you can't use one of them to describe the variable. And actually, this is not so mandatory. What is mandatory is to put the value label. What is exactly what I specifically wanted.
This case, I use
so you can first you can even remove the label. Is it all? So, and also you don't need these decimals. Now, but still, I don't know whether you created it well. That's also another problem. Let me just clear it. You see there are so many spaces. I think there's a problem. So let me just clear it and you do it afresh, right? So you can go back to transform and then record, and then you first clear what is there. Yeah, just reset, everything will be. Yeah, then you start afresh, GDP growth. You give it a name, growth category. Growth, WTH, growth category. No spaces. Then you don't, this label is not, it's not a must. Label is just describing this variable. So if you, it's not in this assignment which I asked, it's not a must. So just go to old and new values and assign the values. So the first one is from lowest up to, remember the first category has less than 5, which means something like 4.9. So lowest through 4.9.
There is no, if you put like this, you are no more precise.
No, there's no problem, because these rates are like, I think, like but you can even put 999, it's fine. It doesn't matter. If they're not many places, many decimal places, it's fine. So that will be 1. And then you add, and then the next one you have to use a range, because there are 2 values involved. One is going to be 5, another one is 10.
So that's when you give a number between a little bit less than the next.
Yeah. Then that one is supposed, you give it a value, it's supposed to be taking a value of 2, and then the next one is all others, and then it's done. And then you go to the value labels from, no, there's one missing, all others. Remember there's 10.
Oh,
Yeah, there is more than 10, so that is all others.
Then I put it.
That is 3, and then you add, and then you finish up, you change, and then okay.
So nothing is there, no problem.
That's the label, variable label. If you want, you can put something to do what the variable represents. Otherwise, you can even change variable view window afterwards if you want. And then it's done. Put those value labels the same way you did for the other variable. Any problem here? Any problem this side? Oh, please don't use just a moment. Don't use variable label, like don't use another variable don't use another variable as a label for another. Like let me show you what I'm talking about. So you say transform, and then you so here, after putting the name of the variable you want, don't use another variable as a label for the one that you are creating. That's a mistake. So if you don't have to think, if you don't have a label to, remember a variable label is a description. So if you have no description to put, you can even leave this one blank. Or you can just think of a description, for example, the dummy variable for high manufacturing share, something like that. But you can leave it there like that if you don't have anything. Yeah, like you normally with descriptions, you have to think of something which will make you remember. Remember that one has, you can have a space because it's a description, so it's not a variable name. But of course, okay, I will suggest that we don't put, because even the variable, the description wasn't clear, but I can say like dummy variable for high manufacturing, or one if manufacturing is greater than that, something like that. But mainly that's, you can think of anything you want to put, and then you have already done this, 7, and then, no, you have done it wrongly, yeah. I have to remove. It is the one which is from lowest through value. So anywhere from 0 up to 7 is supposed to be given a value of 0, not 1. So you add, and then all others will be taking a value of 7. Or you can even start from the other way around and first define more than 7, as long as the value still remains 1, right? And then you continue, and then you change, and then you proceed. Okay, so I think, sorry? Okay, I think we have finished this part. Yes, please. On? Mistake. Let me see the mistake. You have to find? Yes, you define this here, right?
But here, there should be something.
No, it's not a must. Here, you're supposed to describe the variable, like what is exactly this. Like maybe you can say categories of GDP growth. That's just a description of what this variable growth category represents. And it's not a must. It only depends on whether you want or not. The same applies to here. If you want to say something about it, you can. If anything that you can that can help you to remember what you were doing, should be fine. If you can remember this without having a description, then you can still leave it. So for this assignment, what I wanted most is the value labels. Yeah. Okay, shall we go to the next? Okay. So, as you can see, I think you understand why the final day is for practice, because practice really constitutes a very big part of learning, and I will give you a lot of work to practice on that day, on Monday. So, okay, so for now, the next is, we are still looking at how to transform variables. The next transformation is going to be what we call log transformation, and it's very common when you're analyzing quantitative data. Depending on the nature of variables, many times you find that some variables you cannot do meaningful analysis with them without transforming them into log. So first, so still we are dealing with data manipulation, creating and modifying variables, and then we have log transformation. So log transformation is important. It's important to transform variables into logs depending on the nature of the variable, as I mentioned. So why is it important, and what exactly is it? So you transform numbers from their raw form into log to base 10. So what exactly, how exactly does that help us? That will be the question. Why should we be interested in doing that? And what is the importance of transforming a variable into log? So I think I will, we may have a volunteer maybe. If someone knows a quick answer, you can give it to us. If there's no quick answer, I can give you mine. Does anyone know why we bother about transforming variables into log? Any idea? Do you have anyone who did statistics? Statistics. I think I had someone with statistics. I think, where was that person? Statistics. I think okay, economics. Okay. Those from economics. Has anyone done econometrics? Sorry? A long time ago. Okay. Okay, so has anyone done econometrics? Anyone else? Econometrics? Yes. Sorry?
The first year.
In the past year. Yeah. So, okay, still log. Okay, mathematics, because mathematics or applied mathematics, something like that. Maybe some of you have. Okay, so, okay. Don't think about data so much. Think about a function. If you did mathematics, think about a function. So what exactly does log transformation of a function help us? Sorry? Sorry, the control? Yeah, of course, it's like, switching between log and exponent, yes. So the logarithm function, log to base 10. What does it help us if we transform? Because before we think of how to do it, because as I mentioned, how to do is always maybe the easiest, I think, to me. But the intuition is always the most tricky part, and yet it is the most important. When you have results and you're presenting, it doesn't matter how much work you did in the background. When you're presenting it before the ministry officials, let's say they want to have a policy or they are evaluating a policy, what matters is not the econometrics you did in the background. What matters is the intuition of what you got out. So, if you transform something into a log, what exactly are you looking for? Okay, there are mainly two things. Two, but also others, subsidiary reasons. One is that you are trying to kind of smoothen the function. You're trying to smoothen the function because sometimes you have another household has maybe 15,000, then there's a household which has 20 million. Even more than that, right? So if I tell you to plot that on a graph, if you use the normal scale, the usual scale, you may need a scale which is from here up to Chimiro, right? But then it's possible to do without going all the way to Chimirongo because you don't have the whole of that road. So you have just a simple paper here, right? So we can use what we call a logarithmic scale. So a logarithmic scale tries to downscale the very big values and upscale the extremely small values into some relatively meaningful scale. So, for example, having a value of 1 million and then 100 million, you see that difference. But then their logs are not going to be very different. They're going to be different, but not as extreme as the raw values. So by transforming those values from the level, we call it level or raw form, into log, it means that you are trying to scale them put them into a reasonable scale which is not so much diverse. So then, as you got, for example, you know that log to base 10 of 100 is 10, right? And that of 1,000, that of 1,000 is 3. I mean that of 100 is 1, right? And that of 100 is 1. That is what that of 10 is 1. That of 100 is 2. The one of 1,000 is 3, like that. So if I have y, and then I have log y. So if I have like 10, 100, 1,000, and then I have 1, 2, 3. So if I'm plotting, which is going to be easier? To get a scale, a normal scale, which can represent 10, 100, and 1,000. It's very hard, right? Let's even make it harder, 10,000. So you can imagine, how do you plot this one? But you can plot it. Everyone can see that you can easily plot this one, right? So that's one of the reasons why we do log transformation. So this is one reason for easy graphical representation using a simple and reasonable scale, which is logarithmic. Then the second reason is in terms of what we call outliers. And maybe the question is, what are outliers? Should I assume that everyone knows outliers, or should I explain? Explain? Okay. Or should I, let me use a volunteer who knows to explain. Outliers.
Extreme values, like very, very far apart from the...
Yeah. So outliers are they're extreme values, either extremely small or extremely big compared to the rest of the values. So if you have outliers, of course they affect your results, whether summary statistics or regression, they affect your results. I'll give an example. If you want to see the effect, you want to do a regression to see the effect of, let's say, education on wages. And then you have, let's say, in the range, you have a range, people with years of schooling, like, let's say, 10, 11, 12, in that range. And then, let's say, incomes ranging between, let's say, 30,000, 40, 50, 60, 80. And then you have someone with 0 years of schooling and has 100 million of income, right? So you can imagine what happens to the mean, right? The mean will be very big, so it will be misleading. But also when it comes to regression, who knows regression? When it comes to regression, okay, maybe no. So when it comes to regression, to see the effect, okay, in simple terms, to see the effect of, to see quantitatively the effect of education on wages, you'll find that it will be negative. Or let's think of correlation before we go to regression. Let's think of correlation. The correlation will be negative. You know why? Because someone who has a very big value in terms of income happens to have the lowest level of education. So the interpretation which we get, which is wrong, is that the lower the education, the higher the income. And the higher the education, the lower the income. But is it true? No. It's because of the outlier, the extreme values of income for someone who happens to have 0 years of education. So now that's another problem if we use income without transforming it to log. So we have that effect being very strong and misleading. So that's one way, that's another reason why we transform from raw values to log, it doesn't take away, it doesn't 100% take away the problem, but it tries to neutralize that problem, so that the effect, if that effect is negative, at least it doesn't become extremely big, right? So try to minimize the effect of that outlier on our analysis. That's also another reason for log transformation. And then the final one is what we call distribution. The distribution. So it improves the distribution of the variable. I think I prefer to show you this. When I start showing you graphic analysis. We get a variable, we present its distribution in a histogram, and then we also present its log transformed values, and then you can compare the two, then you can understand, you can really appreciate the importance of log transformation when you see those variables. So now, having known the reasons for log transformation, how do we do it? That's the question. How do we do it? So how we do it, still it's a transformation. So we still go to transform, and remember when I say I'm assuming that when I say we go, so simultaneously we are all going there on our respective computers. So we go to transformation, so transform. This time we are not recording, we are computing. We are conducting a mathematical computation on a variable. We are not just changing, because why we cannot do record is because with the record we knew what to be changed into what. But here computing, we have to apply a function on the entire range of the variable. So that's why we don't do record, we do transform and then we compute. So we are going to apply a mathematical formula on the entire range of values for a particular variable. So therefore we go to compute, and then I think you can't see, but it's compute and transform and then compute a variable. Okay, so we can do that together. So it is transform, compute variables, compute variable. Okay, so okay, so is it easy to see here? Yeah, I think you can see. So transform, compute variable, and then you have a dialog box there. You have to put the target variable. So target variable is the name of the variable that you want to create. So not the one that is going to help you to create. So you are targeting to have that variable, let's call it log GDP. Log GDP PC. So we have a variable GDP, it's GDP per capita. That variable is there in your data set, and we want to create a log transformation of it. So we have to say, we have to create log GDP PC. So log GDP PC is our target variable we want, and then it's going to come from the log transformation of this. In other words, we want to have log GDP PC equaling to the log of GDP PC, whereby log is a function. I see some lost faces. Who is lost? Is anyone lost? Or maybe I may have observed wrongly. So okay, I see following faces only. Okay, yes, there's a following face here. Yes, please. What to put there? Okay, no problem. I'm going to show you. So, okay. Okay, so, yeah, so then you need to have the expression. This expression which will tell SPSS that it's a log transformation. So, how to do that? Those of you who use Stata, you know it's just direct. This is like log of. But for SPSS, it's LG10, which is log to base 10. So LG10, as you can see, LG10, then bracket, the name of the variable which you're supposed to transform. Remember, we are not replacing, so that's why we have a new variable name, log. But then we are going to do log to base 10. That's why it is LG10. It means log to base 10. And then for that variable, GDPPC.
That's when you write it by hand.
Sorry?
LG10, write it by hand.
By?
You write it, you type
Yes, you type it, yeah. So this is the expression. Okay, so okay, so I think you have all created it. Log GDPPC, it's created. Okay, for that one, the decimals are necessary because log has decimals. Yes, please. Log GDPPC, and then you put the expression. The expression is LG10 bracket GDPPC. LG10. You can use capital letters for LG. LG10 bracket, yeah, GDPPC. And then click OK, and then it's done. Okay. Has everyone done that? Not yet. Okay, you need help there? Yes. Oh, okay. And next, so when you read, okay, just don't, oh, you removed it. When you get an error message, so normally when you're working, SPSS is communicating with you. When you get an error message, always read what it means. So sometimes you say the expression is not recognized or something like that. So okay, someone did like log 10. So log 10 is not a function. It's LG. This is a function in SPSS. This is not a function in SPSS. Okay, so all right, so how many people have finished? Has it worked? Okay. Okay. Any progress there? Okay, good. Okay. Can I see the, yes, okay, LG10, yeah, you did it. Sorry?
You have that.
Of course, also you have it there. Yes. You have it. Go to variable view, you will see it. It's there. And don't remove decimals for this variable because when you have log, 3.5 and 3.7 are totally different. So the fact that there is a very big, normally there is a very slight difference, but the actual value corresponding to that log is actually big. As you can see, the difference between 100, let's say the difference between 10 and 100 is big, but the difference between 1 and 2 looks small. So don't remove decimals. So 2.5 is very different from 2.7. Okay, so, sorry?
2 decimals.
Yeah, 2 decimals will be enough for this. Yeah. Okay, so now, how can we check the distribution? How can we check the distribution of this variable? This is going to take me into the second phase of the training, which is graphical representation of data. So I want to show you the distribution. I mentioned that variable. This is going to take me into the second phase of the training, which is graphical representation of data. So I want to show you the distribution. I mentioned that log transformation improves the distribution of a variable. I don't know whether, has anyone heard of normal distribution? Somewhere during any course or any professional work, some of you could have heard of normal distribution, right? But for those who haven't, I can just do in like less than a minute. So someone has seen that somewhere. Okay. So normal distribution means we have so normally we have a parameter. Let me consider mean for simplicity. So you have, for example, the mean of a variable. Let's say age. So if I say the average age for this class is, let's say, 30 years. It's just an average. So for this variable age to be normal or to be normally distributed, we expect to have, of course we don't expect to have everyone to have 30 years, but we expect that if the mean is 30 and this variable age is normal, then we expect that the number of people who have below 30 will be approximately equal to the number of people who have above 30. Then we have a midpoint as 30. So that is in very simple terms, that is normal distribution of that variable. So, but then sometimes you find that it's not the case. Actually, many times you find it's not the case. You find either more people have less than 30, or sometimes more people have more than 20, and then you have what we call, I'm trying not to use so many statistical terms, but we have what we call skewness. So we have a skewed distribution either to the left or to the right, okay? So if you don't know skewness, it's not a problem, but for those who have heard of it, you know that when it is to the left, then it is skewed to the left. Left is skewed or right skewed. Okay, so then with the log transformation tries to put it more towards a normal distribution. So it helps to kind of normalize this variable into following some kind of normal distribution. Why is it important? A lot of statistical analysis, which we shall do, will be assuming normal distribution. For example, regression analysis, and even simple tests like hypothesis testing, like a t-tests, the assumption is normal distribution. So if you are dealing with a non-normal distribution and you are applying a test which assumes normal distribution, already you are into statistical trouble. Okay? So that's one of the reasons why we do log transformation. Now, we have done it. How can we check what we have done? The distribution. We are going to do, so a histogram is one of the graphs that show distribution of a variable. So we are going to have two histograms, one for GDP per capita, which we have just done, and another one for log GDP per capita, so that we can see how the distribution differs between the raw values and then the log transformed values. Okay? Then the question is, how do we do that? Any idea? Any idea on how we do the histogram? Analyze, yes. Sorry? Descriptive statistics. And then descriptives, yes, not so bad, but also depending. Okay, there's also frequencies. Sorry? Yeah, just a moment. Sorry? For interpretation? Sorry, I don't understand. Can you clarify? Is it a question? You mean, you say why we present? Sorry, I'm struggling to understand the question.
You see, we corrected that into the analyzation of it. Analyzation, we present what by using
Yes.
the log transformation. Yeah.
So log transformation is not necessary to help us in interpretation, but it helps us to normalize a variable so that it follows a normal distribution. And why? Because one of the reasons, of course, is to make sure that outliers are somehow neutralized, but also to make sure that some of the statistical procedures which assume normal distribution can be applied. For example, the t-test, which I'll be showing you when I start teaching inferential statistics. Yeah.
When you want to see if two variables have the relation between them, okay?
You mean when you to do normal distribution? No, it has nothing to do with correlation. It has to, just like you say, if you, let's say, if you are going to take, let's say, advanced SPSS, then the condition for that to work well, the condition is that you must have done basics and intermediate. So it's just a condition. So the same applies to tests. If you're going to apply a t-test, which I will show you later, if you're going to apply a t-test, it has a condition. The condition is that the variable should be normally distributed. So if that is the case, then it works well. If that's not the case, then there may be some issues. Sure.
Let's assume we have so many cars in the playground. Let's assume that we have so many cars in the playground, and we just allow them to move at the same time. It will create a lot of conditions in the playground. Probably they may even collide each other and cause problems. So rho is like
channeling all of those cars in the playground to make sure that they go through the same paths and avoid problems. These problems are the ones they are talking about being outliers. The data that causes a lot of conveniences to scatter away from the way that graph is.
Away from the mean.
Away from the mean, from the value you need. So that is the importance of having our data first of all goes through raw. That's the way I understand.
Okay.
It's not about trying to avoid problems that the data should be having. It's the outliers. Twende n'ufata byinshi bikongese ukabibuza gukomeza transformation, yes. You are taking a lot of data, just combining them into a small things, and something that you can easily analyze. That's the way you know, sometimes when you are analyzing data, you face problems. For example, the results that you expected from your data, you divert from what you expected. Okay? And that's why sometimes statistically you go through procedures of software that help you to give the data that you anticipated to have.
Okay, yeah, thank you for the explanation. And then I also add on, for what reason? So for what reason is exactly what I was saying, that if you have, so one of the reasons is that for normalization and also neutralization of some of the outliers. So having very big values, there's a lot of variation, and then that variation can somehow be scaled up into some reasonable range. And then also, of course, as I mentioned, that we are going to do hypothesis testing, and one of the tests is called a t-test, and a t-test works under the assumption that there is normal distribution. In other words, it works well if the variable is normally distributed, and if it's not, then there may be some issues of validity of the test. So that's why instead of just working with the raw values, then we transform into a normally distributed variable by log transformation. Okay, so then, yes, please. There are many ways of dealing with outliers. Sometimes you find that the outlier is extremely big or extremely small, and you have to get rid of it. Yeah, but even remember, it's not outliers. Outliers are not the only threat, but also the extreme diversity. Sometimes there's diversity even within the range, not necessarily those extreme values, but also even within the range there's a lot of diversity, and then that can be somehow neutralized into some meaningful diversity by log transformation. But of course, sometimes you have very big outliers or very small outliers, and you have to even get rid of them. Yeah, it happens on who wants to come, right? It's just by chance that we don't have anyone of 80 or 15, but it can happen. It doesn't matter how many we are. We can even come when we are 5, and one is 80. So it doesn't matter how big the data set is. It can happen anytime, anywhere. It depends whether the data set is small or extremely big. Even sometimes you have a very big data set without any outlier, and then you have a very small data set with many outliers. It happens. Yeah. Okay, so let's now do the histogram. So you asked the question, can't we go directly to graphs? Yes, you can go to graphs and choose histogram, but of course there is also an issue there. You have to know the dimensions. But if you go to analyze, and then we go to descriptive statistics, and then frequencies. I repeat, if we go to analyze, descriptive statistics and frequencies, we can get histogram from very many sources, depending on how we want it to be structured. And then we choose the variable. We are going to do GDPPC first, GDPPC, and then we choose the statistics we want. Let's say we are going to have, okay, we can leave it like that for now. Let's first choose the chart, and we choose the histogram. Yes, please.
Are we going to go to GDPPC or log?
We are going to plot both of them, but one by one. So first I started with GDPPC. If anyone didn't follow me, I go back. So I go to analyze descriptive statistics, frequencies, and then I choose which variable. I start with GDPPC. Then I have to specify the charts because this histogram is a chart. So I go to charts and I choose histogram. And then I click continue, and then I click OK. Okay, then I wait for it to be produced. So depending on how fast your computer is, it may take long, it may take a short time. Okay, so now here the values are not so many. They're just within a certain range, but still you can see that it's not, okay, it's not appearing to be organized in that shape, right? So it's not normal. So how about the log of it? Log GDPPC. You can check and see whether it has, sometimes it doesn't necessarily mean always when you log transform it becomes normal 100%. No, just trying to make it move to resemble a normal distribution as much as possible. Okay, we can do it together here. So you go to analyze, descriptive statistics, frequencies. Then in your case, I think you're still doing GDPPC. In my case, I'm doing log GDPPC. So I put, oh, I didn't do it. Okay, I have to do it first. Oh, I think I did it actually, it's there. Okay. Okay, so after this is where you asked, after putting the variable, then you go to charts, because you need to specify which charts you want. So by default there's no chart, but in my case I already selected histograms. So I continue, and then I click OK. Okay, so it has tried to scale them up a little bit, but of course it's not if you do for example GDP, I think there will be a very big difference between GDP and log GDP. But and also when it comes to like countries, when it comes to countries, like if you have other countries, so then you have diversity between years for the same country, like we have here. This is Rwanda only, but also we have diversity between countries. So that also makes the raw values very diverse. And then also when we do log transformation, then there will be a big difference between the raw values and the log transformed values. Yeah. But still you can see it has somehow tried to move towards some kind of normal with some moving towards the center a little bit. Of course, not 100%, but not as the same as the raw values. Yeah. So sometimes you transform a variable and then it almost 100% becomes normally distributed. Yeah. Okay, so basically that's it with that. And we shall be using it also when it comes to the analysis that follows. Yes, okay. So now let's do some simple graphic analysis, and then this will take us to the end of the lecture, and then tomorrow we shall come back and do some more graphs, and then move into descriptive analysis, inferential, and then regression, and then we see how to move into time series analysis, panel data, and then finally into qualitative data analysis. Okay, so let's look at a graph like this. Very simple. It's a very simple graph. It shows the trend of GDP per capita over time. So the only question is how to do it. I think how to interpret it, I'll get someone to help us. But let's start with that as our starting variable. So how do we do graphs? As you mentioned, you can go through graphics, or depending on what you want, some graphics are available.
Not because I have any knowledge about that one. Because I was...
You were seeing but you were actually right. You can go to graphics and look for histogram. Only that, so there are many ways to do things, especially when it comes to descriptive analysis. I'm going to show you. There are many ways to do the same thing, but the way to do it matters. When you do histogram, which you get from graphics, then it assumes 2 dimensions, the y-axis and the x-axis. So in this case, then what will be on the x-axis? We just want frequencies of the same variable. So frequency is not a variable, but we have a variable GDP per capita. So in that case, when you go to graphics, you are going to be forced to have a variable on the vertical axis and a variable on the horizontal axis, which we don't have in this case.
For example, when you are analyzing
When you're analyzing?
like 2 different parameters, that's where
Exactly, yeah. But in this case, it's what we call univariate analysis, one variable. We want to see how it is distributed. So then frequencies will be the best way. Analyze, then go to frequencies. Okay, so let's do some line graph of how do we show the trend of GDP per capita for the, I think I used a different data set, so, but it's fine. So yours will be up from 1981, mine is from 2008. So let's do the graphical analysis of GDP per capita for Rwanda. We go to, you see there is a graphics tab here, graphics, and then chart builder, and then you are asked before you use this dialog, blah blah blah, then you just say okay, and then you are given a chart builder. So I think one of the reasons I told you why people like SPSS is because it's easy. So now you have the graph. You have it's like an empty scale, an empty frame, and then you try to put in some variables, and then you see a preview of how things will come out before you proceed to print the output in the console. So, okay, so in this case, we want to have a line graph. Of course, you can see there are so many graphs, and you have to always know different graphs represent different information. So why should I choose a line graph? Because we want to see the trend of GDP per capita or GDP growth over time. So, and the line graph is specialized for that. It's always important to know what exactly do I want. It helps you to know which graph to pick. So in this case, we want to see the trend of GDP per capita, so we choose line graph. And how do we choose it? We have, you see, we have two options. Then to pick, we just pick the simple one, so a simple line. So drag it and drag it into the plot, the chart area. As you can see, I drag it into the chart area like this. I throw it there. Okay, so as you can see, when you after throwing it there, then I have the axes waiting for me to put which variable goes where. So how do I want it to be? I want it to be like this. I want GDP per capita to be on the vertical axis. I want years to be on the horizontal axis. So you may wonder why I have mean. In this case, it was mean because I did it from a data set which had other countries. Then I had to plot the mean of the GDP per capita for the respective years. Okay, but in this case, we don't require mean. We're just going to present raw values. Okay, so I think everyone has this graph, right? Okay, so then how do you take, there are things we can do about it, like we have to add a title, and there are many things we can do, but how do you take this graph to Microsoft Word? Because of course we are assuming that the reason for doing this analysis is because there is a report or a paper or whatever that you are trying to do, or a presentation that you are trying to do. So I'm going to show you both in terms of presentation and also in terms of Microsoft Word. So for Microsoft Word, it's easy. It's very easy. You just copy.
Those are the data.
Sorry?
The data you are using, I think they are true.
Sorry?
The data we are using.
Yes, please.
I think they are genuine.
They are two?
They are genuine.
Someone is saying he thinks, okay, why do you think they are genuine?
That's both of
Okay, someone is saying, someone is thinking that the data we are using is genuine. As I mentioned, this is not simulated data. This is data for Rwanda. These are macroeconomic indicators for Rwanda. They are the same variables Minecofin uses for planning, modeling, forecasting. Even when I'm teaching like macroeconomic modeling and forecasting, still they are the same we use. They are the same the chief economist uses in Minecofin to do the planning. So they are genuine. As you mentioned, yes, they are genuine. They are actual data sets. They are not simulated. Okay, so that's what I always say. That when I'm teaching, I use actual information. So when I'm teaching in Uganda, I don't use Rwandan data, because I need, wherever I go to teach, wherever I teach, I make sure that what I teach is appropriate to the context of the country. So this is actual data of Rwanda. Yeah. So I say, I was happy you realized it's not, he said, it seems to be genuine. And in okay, so you copy the graph, and then you take it to Microsoft Word. Claude, do you have Word on this computer? Claude, do you have Word on this computer? You have Word? Microsoft Word? You have? Okay. Let me check. Okay, so when you have this graph, you just copy and then paste. But I'm going to show you if it's PowerPoint, because you may be interested in presenting. It may not be, some of the figures, tables may not be easy to, may not directly come into PowerPoint. So for Word, it's just easy. You just paste, and then the graph comes, and then you continue writing your report and make some description, like so. But before that, let's do one more graph, and then someone can help us to interpret that graph. So, okay, the one who said it looks to be genuine. I think you already have in mind the trend of these variables. So let's do one for GDP growth, and then you can even just a moment. You can even compare with what is in the reports in different ministries or different even international outlets. Yes, please.
Can we get that one?
Sorry?
I thought giving it like a title difficult.
No, it's not difficult. We are going to do that. Let's do the one for GDP growth. Then someone will interpret, and also we give it a title at the same time. Yeah. So just go through the same steps. Go to graphics, chart builder, then okay. Remember that when you come to the chart builder, you find that the information you left is still there. So if the type of graph has not changed, you just pull out the variable GDP-PC, and then just take GDP growth into the vertical axis, and then on the horizontal axis there's no change, it still remains the year. I removed GDP-PC and I put GDP growth. So I'm sure someone has seen this graph somewhere. Has someone seen this graph somewhere? I'm thinking that you have. If you haven't, you can check it out. I'll give you one place where it is, and it is well described. It is okay. So if you want to know more about Rwanda's growth over time, you can check out that paper, and also it's a book chapter. So it's the growth is well explained, the trend, but also the reasons behind the trend for those different time periods. You see there's a time before the 90s, and then there's a time from the mid 90s up to, let's say, 2000, and then there is a recovery period after 2000, and then there is a period of sustained high growth. So you can check out those in that book for those additional explanations. But in this training, someone can come up with some interpretation of the trend, but also maybe some of the reasons why we see that trend. Anyone to interpret the line graph? Anyone to interpret? Maybe, I think you wanted to say something about the trend.
Use GDP growth as what?
GDP growth is the variable that is on the vertical axis.
It is average, because they are using mean growth, GDP
So that's fine. You're wondering why I'm using a mean, right? So mean, so it's just like the line graph is looking at mean, because sometimes you have to plot means of values. For example, you have many countries and many years, and you have to plot means of their GDP growth for each year. But in this case, it's one country, so the mean of growth rate of 1 year for the same country is the same as the value itself. Yeah. So this is the same as just the plot of the actual values. Okay, so can you interpret the trend?
So I see that we have been around 6,000.
No, actually, don't worry about the numbers. This is growth rate, percentages. Growth is in terms of percentages. Like you, I think you've heard of Rwanda has been growing at a rate of about 8% for the past almost 20 years, right? That's the part that you are seeing. There's some small fluctuations after 2000. So yeah, there are some fluctuations, but at least you see that the rate is almost constant. It's about 7.8 for the past 20 years.
But is it of the peak?
Sorry?
The peak, the highest. It seems to be, I don't know if it is real. That's
You don't know whether it's real? Yes, it's real. Even this one. Even this is real. Yes, it is real, and I'm going to give you a reason why. I saw a question there.
No, she was saying the reason why.
Okay. So you were giving the reason, right? Okay. So yes, and okay, you're right. So okay, you picked out one or two values, but I wanted the whole trend. The whole trend, right? Because when you're interpreting your graph, then you have to think about the whole range of values. Who can do it with the whole trend of the variable? How would, if you saw something like that, assuming you saw something like that, and then let's say you are in a conference, and then you are captured by a news report and say, okay, come and tell us about this. Say something about this. You are on Rwanda national television. What would you say? Of course, explaining the trend, but also giving some reason, because when you are giving expert opinion on something, then you're describing and also giving the reason. Okay? Yes, please.
from 1980, the GDP growth was around 8%. And
was it 10%? I think it was lower than
around 2 to 3%. Then it decreased as around 1981. To see there was a decline. And went high again as we approached 1985. So the GDP was, to some extent, decreased beyond 1985, and it will be hard to almost the same level of around 1980. it went on to increase a little bit up to around 1986, 7, things like that. But what is something that is a little bit critical is in the year 1990 to 1994, where tremendous decline. And around 1995, between 1994 and 1995, there is an increase. That when there was a sharp increase of the GDP compared to the rest of the year. And before 2005, the GDP and the trade almost stayed constant up to 2015, where the GDP between 1995 and 2015 showed to be 88%, and it remained constant.
Okay.
Compared to the rest of the years.
Okay, good. Yeah, thank you for that. It's a good interpretation. Maybe what I can add is that, yeah, so there will always be fluctuations, right? Some of them are small, others are big. So in this case, we can ignore some of the small fluctuations in the interpretation, but we focus on the main fluctuations. So when I look at this trend, what I have in mind are three phases. I have the phase before 1994, and then the phase between 1994 and 2000, and then the phase after 2000. So what I can say is that Rwanda was growing at a rate of around 3% before the genocide. And then when the genocide happened, then the growth rate declined to almost minus. By the way, this is not zero. So we have somewhere zero is like here. No, it's actually up to zero is somewhere. Oh, zero is somewhere here. Okay. So after the genocide, like during and after the genocide, the growth rate was a little bit lost. It actually became negative, and then afterwards, so we have what we call the growth period after 2000. That's when we have had growth rate almost 8% for the past 20 years. So of course it's clear what happened during this period, and someone was wondering. Someone is saying, okay, this one he understands, but this one is not real, right? So okay, why is this one real and this one is not real? Oh, so this is like negative. I remember it is like negative 50%. Yes, because of course the economy went into shock. It went almost to zero, downwards. So and then of course, I think you understand when it is negative, right? It doesn't mean that there is negative income, or it doesn't mean that there was no production or whatever. But negative because these growth rates are in comparison with the previous. Okay, so that's what makes this genuine, according to you, genuine. This is genuine, yes, because before that we were somewhere here, and then we went into shock. So this one compared to this one, this is a big negative. But then what makes this one also genuine is because we moved from a tunnel to somewhere. It doesn't mean that we were on the top of a mountain, but we moved from somewhere, from the bottom of the valley towards somewhere, not necessarily at the peak, but somewhere, right? So, whatever we had here, it doesn't necessarily mean that we are very well off, but it means in comparison to the way the situation was before, right? That's what created this big positive recovery. I'll give an example. It's like saying, if you get two people and one person has an average income of, let's say, 5 million per month, and another one has 5,000 per month, then you get 1,000 and give it to both. The one whose income is 5,000 has got an increase of 20%. But the one whose income is 5 million has got an increase of a very small amount, which you cannot even think of. Very small, right? So therefore here it was a treat. It is, as you say, the data is genuine, so which means also the graph is genuine. All points of the graph are genuine, right? So there's no simulation here. It's actual data. So it was a very, very good, very big progress. Like people are now very happy, they are very rich. Not necessarily that. It's just because from somewhere deep to wherever we were, that was a very big improvement. So that's why the growth was almost 40% positive. Yes, please.
When we have some data missing with data correction, can you not have the same graphic which can show you that there is which look like that one?
When we have missing data?
When there is missing data, when you were gathering some information from the field, and you miss some information.
Now, when you have missing information, it doesn't necessarily mean that you will pick up from a high rate. Let's say, okay, let's assume we have information here, and we don't have information, let's say, for some of the years. So it's just like thinking of cutting off this part. But when we catch up on the next year, it starts from where it's supposed to be. So this has nothing to do with this. This is a structural break. It's a structural break. It has nothing to do with which information was missing. It has to do with exactly how the economy was behaving. If there is missing data somewhere, then when you catch up, it has to pick up from the reasonable trend which it was supposed to follow before this data was missed. Yeah. So totally different from missing data. Missing data will just have a break. It's like cutting off part of the function, but then it doesn't create this structure break. Okay, so how do we create a title? And then how do we take the graph to PowerPoint for those who may be interested in presenting? So to create a title, you have to, there are many things you can do. You can create a title. You have to double-click the graph. Double-click the graph and then modify. Sorry? Sorry? Sorry, can you? Yes. Yeah, you double click from where it is produced, and then under options you can add a title. So you add the title, and then you see that you have a space. So within the SPSS results window, so that's you go to double click the graph, then you go to options, and then you add title. Then you type the title, for example, like Rwanda's graph, line graph. So then from there, when you exit the editor, then automatically the graph will be modified. So you can see that another screen is displayed for you to modify. And then when you go back to, sorry, I had to double click, and then I go back to the, okay, so when I double click, then it goes back to the to my environment where I get the variables. Sometimes it takes long, sometimes, okay. So depending on how slow or how fast your computer is, it may be. Yeah, so mine has come already. And so I've added the title, and now I can copy and then I paste in Microsoft Word, just like we have done before. But for PowerPoint, because I know some of you may be presenting your work, for PowerPoint it's not, when you just copy and paste, it may not work. So instead you have to copy special, and then when you paste also, you paste special. So for Word, just direct, it's direct. For PowerPoint, copy special, and then you have to choose how do you want to copy it as special. So you can have an image, or you can have a meta file, EMF, enhanced meta file, and then you click OK. Okay, so let's do it together. So you have created the graph, right? Or how I put a title? I double clicked the graph, and then it brought title. I mean, go to options. You have a box where you choose options. You double click the graph. Yeah. Then you. Okay, so copy. So right click, copy special. Copy chart? Copy chart? It's not giving you copy special. But it's still, really? Okay. Right click, copy special. Let me see what you have. No, not from here. This is for you to put the title. It's not the one. You go to this one. Yeah, that one. The other one is just helping you to make changes. It's like a chart editor.
So, and then I choose this one.
Then you go to this one, you right click, copy special.
Okay.
Yeah. So right click, copy special, and then you you select meta file, EMF, which is enhanced meta file, and then you click OK. And then when you go to PowerPoint, so when you go to PowerPoint, you don't just paste, you also go to paste special. So paste special, and then you choose picture, which is enhanced meta file, EMF, and then you click OK. Then it will be there. Yes, please. Not from there. You have to do that from the results window. So this is like a chart editor. That's a chart editor.
this one.
Yeah,
No,
from there.
No, this is what I.
Oh, that's from Word. Yeah. Yes, from there. Yeah.
From this pen.
So that's one way to do that. Another way is to copy and paste in Word and then copy from Word into PowerPoint. Still, it is still the same. Yeah.
Go to PowerPoint.
Sorry, can I have one by one? Okay. Similar. Okay. Okay, yes, please.
PowerPoint.
Yes, you go to a new one and paste it wherever you want it to go. But paste special, paste special. I'm saying you have to paste special. So if you're taking PowerPoint, there are two options. Either take it to Word first and then copy from Word into PowerPoint, or copy special and then paste special. Paste special is here. Yeah, here. Yes. Yes, yes, it's there. Then you choose any enhanced, but you haven't yet copied as a special.
I did.
That's why it's not giving you the paste special option.
This is.
Okay, even image, you can also tick image, then okay. Yes, no, I mean, leave them, fine. Yeah, then okay. Then go to PowerPoint, paste special, and choose enhanced meta file, EMF, picture EMF, enhanced meta file.
Oh, and always.
No, just not always, depends, then okay. And then it will come. Okay, so you want to rush out?
Yes.
That's fine.
Are we done?
Yeah, for today we are done. I'm just going to check around for a few minutes. Otherwise, for today we are done. Tomorrow is at 9 again. Yeah, so tomorrow, just briefly, tomorrow we shall do more graphic analysis. We shall do descriptive analysis, and then we shall do inferential statistics. And depending on how the speed will be, we might move into regression analysis. And then the final days we shall do time series and panel data and a little bit of qualitative data. Yeah. Okay, so officially I've closed the class. Thank you for coming, and looking forward to to meeting tomorrow. So I'm just going to stay around for like 5 minutes in case someone has a question. If there are no questions, then we shall be meeting tomorrow at 9. Yeah. Yes, at 9. Yeah.